food production and human life goes hand in hand. We need to have food security, we need to have water security to sustain in this planet for the future times. And then comes and that leads to actually the Sustainable Development Goals, the United Nations Sustainable Development Goals, the 17 goals that we are most aware of, almost all of are aware of. And out of these uh, 17 goals, you would see that uh, at number 6 specifically, but then there are other at least 7 goals which are directly related to the availability of the water and the food production associated with it, starting with number 1 and number 2, which are no poverty and zero hunger. So SDG 6, clean water and sanitation. So as we speak about water and as we speak about a better life in the future, one of the prime thing that as a one humanhood, one world, we have concept is to have clean water and sanitation. And I took this diagram from the United Nations site where they're showing a cartoon where people are using the same water for their bathing purpose, for their sanitation purpose, for their drinking purpose, for their other household purpose. Now that would also relate to health issues. So in India, estimate shows that almost like 107 million people are affected by groundwater pollution. Now that 100 million is actually a very conservative estimate. It possibly is more like 200 to 300 million. And again, these numbers are a little old, but at present, I think this is more like 300 million. So you can think of the whole population of the US, which is close to 300 million, are just not having good water. So it's just not a problem. It's just not a science problem. It's a societal problem. It's a problem of our survival as human in this planet. And one of the major cause of this pollution is the deaths because of unsafe water, sanitation, and hygiene. So we are not having clean water, just not from the geogenic pollution, but also from the sanitation and hygiene sense. So we recently published a couple of papers, and I'm going to base most of my rest of my presentation through these papers. So you are welcome to take a look at this. So what we did is we collected data from about 1.7 million locations across India for groundwater fecal coliform concentrations between 2002 and 2017. So around 20 years, not exactly 20 years, around 20 years, 15 years. And what we did is we tried to calculate out the changes in trends, or whether the groundwater pollution because of fecal coliform is increasing or decreasing. So the bar that you see at the down below, it is showing that the blue is good, so blue is increased safety or decreased pollution, and red is bad, which is increased pollution and decreased safety. So what you can see, the whole country has a very, very vivid color distribution. So while in some places they're quite blue, but in other places it is somewhere between yellow and red, which tells us that this is a problem. So India is not actually having sanitation development and the clean water access because of that in the same way that it should happen across the country. Now, what I'll do is, as we go through, just to understand with the other controls, I'll also focus in these 4 study areas: area A, which is highly improved; area B, which is somewhat improved; area C, slightly improved; and area D, not improved at all. Okay, so we will also come to this area A, B, C, D as I go through the presentation. So this one, just like we did for the sanitation, groundwater sanitation pollution, we also collected health data, acute diarrheal cases. And as you would know, like acute diarrheal cases is one of the largest killer for children for sure, but also for higher populations. And estimate shows that at least 1 million children dies in India every year, just not having clean water and suffering from acute diarrheal cases. So again, as you see, like the whole country has a very different picture. Again, blue is good, where aqueductal cases has come down, whereas red is bad. It has not come down and possibly has become worse. So as I was talking about the area A, B, C, D, and the entire area as green. So what I'm going to show you is how the trends have changed over the period of time. So somewhere between 2002 to 2017 for the first plot, which is for the FC, which is the fecal coliform, and where the next one is for acute diarrhea from sorry from 1990s to 2016. Now you also see that there is a light blue bar on the side, and this bar is actually indicating from 2014 onwards. And as some of you might know, that in India from 2014, with the change of the government, there has been more stress on groundwater protection and better sanitation in terms of a project called Swachh Bharat Mission. It's a mission project, and through this project, they wanted to stop pollution and thus, I'm sorry, stop open defecation as sanitation, and accordingly, reduce the groundwater pollution, which was not very openly discussed about, but that's what it is. So when we correlate the fecal coliform anomaly or changes with the acute diarrheal changes, you see the map that I'm showing on the right. And what you see, again, blue is good, red is bad. What you see, again, much of the areas across the country is blue, which tells you that the acute diarrheal cases that we have observed across the country are actually related to the fecal coliform. And at the same time, as the fecal coliform is supposedly decreasing because of enhanced sanitation structure construction, the acute diarrheal cases are also decreasing, which is, of course, a positive thing to look at. So drivers. So we talk about the sanitation development and what has happened. And as I told you that since 2014, a huge number of construction are going on in terms of development of sanitation structures. So the question is, and a huge amount of fund has been allocated to that. Now the government is saying, it's 100% the sanitation developed and everything. But what is the real picture according to their numbers? Well, to do that, we have to understand this picture. And this is the sanitation value chain. So it is just not saying that we have built this structure or there is no cases of acute diarrhea or anything, but we have to understand how it is happening. So you have the containment, you have the emptying, you have the transport, you have the treatment, and you have the reuse and disposal. And you do understand that a failure of any of this links in the whole chain actually is a failure of the whole system. So you need to have from containment to disposal if you want to really want proper sanitation. And this map was published in 2014 by Ernst Smith, and where she gave a regional context to what's happening. And as you can see, along with Africa, India, the South Asia rather, not India, just India, the South Asia is one such place where improved sanitation has not happened really as of 2014 data. So Africa and the South Asia are the hotspots across the world. And this is kind of the percentage solved by different types of sanitation systems. And you would see that the green ones, which is the septic, the flush plates or pit-dry, they are some of the dominant structures both in Africa and South Asia. So it tells you that whether we have the proper sanitation or not, that is also a question. I mean, just building a sanitation structure and just labeling it sanitation free doesn't help. You need to put things in context. So what I'm showing you now is the data for annual sanitation structure construction. And again, the anomaly trend shows you the way it has increased or decreased over the years. And again, blue is good, red is bad. And what you see that across the country, you have the sanitation structures being built over the years. However, the building has not been uniform across the country. And again, what it also shows that although we had a lot of fanfare and everything for the Swachh Bharat mission, actually the trend that we're seeing, at least to the plot on the right, it is actually a continuing trend from the 1990s. So it actually didn't start per se from 2014, but it is a continuing trend. Of course, in 2014 there has been an increase, but it is a continuing process from at least for the last 30 years. So what are the influences of sanitation structures development on groundwater quality and health? So these two plots shows you the correlation between fecal coliform anomaly and sanitation anomaly. Again, blue is good, red is bad. We're standing mostly in the green across the country. Same way, the sanitation construction and the aquatorial cases. Again, it's kind of similar with the other map. And again, it's kind of standing somewhere in the green. So we need to go into more scientific processes. Those are data that are mostly released by the government of India. And we need to look for more secular opportunities. So what we went for is to look for the nighttime light as an indicator of economic development. Because when you're talking about sanitation development, the economic development plays a pivotal role. And the government will have their own data, which may or may not be accurate. So we went to look for some secular proxies which would not be controlled by any government or any agencies. So we started looking at the nighttime light that has been released by NASA for every day since the 1990s, and it's still being released so far. If you compute that, you can literally calculate out how the night light is changing over the period of time on a daily scale. And over the period of time, that also indicates the nighttime lamp, the economists have already kind of proved it, that this nighttime light is a good proxy of microscale economic development. It is not accurate, but it's a good proxy. So now we are invoking the nighttime light anomaly, same way that we have done for the fecal coliform and equidaria, to illustrate the economic development across India. So now we add another context, the sanitation anomaly with the nighttime light anomaly, fecal coliform with nighttime light, and equidaria with nighttime light. What you see that the sanitation development and the nighttime light actually matches very well, which suggests that the sanitation construction actually was also driven by the economic development of the region in most places. Whereas the presence of fecal coliform in the groundwater and the aquatorial cases are not seems to be directly always influenced by the economic development or sanitation development, which tells us that we need to be careful before we draw conclusions. So over the period of time, we did see that there are increases in sanitation construction, and so is the decrease uh, death because of fecal coliform pollution. But still, I think there is a lot of way to go. Now, that also brings the human factor. We have not talked about the human factor yet, and it seems uh, the human factor also do play a huge role. So again, we come back to these areas, and now we are going to try to find out the impact of population, the impact of literacy and sanitation usage. We cannot do it for the whole country because we don't have data, but we targeted these 4 areas, A, B, C, D. And we did see that in the area A, where the fecal coliform has gone down the most, actually the population percentage has also increased drastically. So this is the population literacy rate in North India, parts of North India, and how the population, with the population, the literacy rate has changed. But also the sanitation usage is important, and in many places in the villages across India, and I suppose most of South Asia, the sanitation structures are getting constructed, but maybe they are not used, and they are used for some other purposes because they are possibly the only constructed structure in the rural homes. So they are using it for various things, like keeping their cattle, maybe even putting the fuel, and sometimes very interestingly for even creating their worship place. Okay, so the very interesting observations that we had from this study. So at the end of the day, we came up with understanding that it is just not the economic development or just not the sanitation construction that would impact the the clean water and sanitation, access to sanitation or SDG 6, but you need to also change the perception. You need to correct the design. You also need to have access for all, and you need to have social acceptability. So area D, where you had the lowest of everything. Interesting part is that it's just in the outskirts of the national capital of New Delhi. And the reason that we think that this place has not really came up, that it should have, because it's a capital area, because across the capital city of New Delhi, there are a lot of these suburban townships that are coming up, like Gurugram and Noida. And these areas, they have huge structures. They're having huge construction going on, but without having a proper sewage. So consequently, the lot of the people that are living there, the sewage is actually spreading in the groundwater, eventually polluting it to make it the worst in the whole country. And that also brings us that whether sanitation interventions are actually a threat to water supplies rather than making it better. So we did all this analysis and we came up to identify areas where you would have, the economic development and the improper human practices decreasing to make an area much better in terms of access of clean water and sanitation. So, we did all these calculations and we did show area by area what are the factors that eventually helped the sanitation development and eventually the clean water accessibility in terms of fecal coliform pollution across India. And these are more on the statistical sides of it. And we kind of delineated all of this. And we came up with this final flowchart, which is kind of complicated, but I think it kind of shows you a snapshot of what we had observed. I'll be happy to take any questions that you might have. Thank you.
Thank you, Professor Mukherjee. It was an excellent presentation. Really, I will appreciate your presentation. I think due to the time limit, I can't get more questions with the panel. I think I can go considering tight schedule. Okay, I think I can go to only one question from my side. Then I can stop the more
That's
question.
fine. That's fine. You can always email me.
Okay, thank you. While considering the physical and chemical parameter of the groundwater, we do see the fluctuations of the ions and metals concentration for the depends on the pre and post monsoons. In case if microbial contamination, do we observe any such changes in the pre and post monsoons? If so, considering the present state of microbial contamination percentage, what is the realistic predictions for recovery of the aquifer by rainfall recharge?
A very good question. I really, really appreciate this question. It is a work in progress where, this is a work that I presented from 1.5 year back. So, and now we have also included AI, artificial intelligence, and big data analytics. And we are kind of inheriting, we are working in tandem with the Jal Jeevan mission of Government of India. And with the data that they are now releasing to us, we are using the artificial intelligence to bring up the bigger picture. So just basically addressing the exact question that you asked for. So we are trying to integrate all this data into kind of a more numerical platform, if I may say, and not just go for statistical analysis and then going for the prediction. So this is a work in progress. I cannot really comment more than this at this moment, but I really appreciate this question. It's a very good comment.
Thank you so much. Thank you so much, Professor Mukherjee. Excellent. Thanks for your answer. Colleagues, I think this session is Professor Mukherjee as a chair of the sessions. I'm a co-chair, but due to some technical issues, just I hand over as a chair first to two speakers. Now I hand over the session to Professor Mukherjee. He can continue with this sessions. Thank you, Professor Mukherjee. Please.
Thank you so much. Thank you so much for giving me this opportunity to present as well as be the chair of the session. Now again, I cannot start my camera because of some technical issues, I suppose. But you can always see my picture in Google or something. Yes. So why don't I just introduce our next speaker, Do we have our next speaker already lined up, Dr. Hirata?
Yes.
I think
Yes.
he's
Okay.
Professor Hirata. Can you connect Professor Hirata?
He's online already.
Yes.
Okay.
Professor
Thank you so
Hirata,
much.
can you hear me?
Oh, yes, I can hear you.
Okay. Thank you, Professor Hirata. Let me introduce the eminent speaker, the next speaker, Professor Ricardo Hirata from the Institute of Geoscience at the University of Sao Paulo in Brazil. Professor Hirata is a full professor at the University of Sao Paulo and a director at CEPA US and USP, which is the Groundwater Research Center. He's a geologist by training with an MSc and DSc degree from the University of Sao Paulo in Brazil and have a postdoctorate from the University of Waterloo in Canada. He's a former member of the Groundwater Management Advisory Team of the World Bank and had been an advisor to the IAEA, or International Atomic Energy Agency, and the UNESCO. He's also a visiting professor to several universities in Costa Rica and also in Calgary, Canada. He also has more than 36 years of working experience in 25 countries, and that the studies includes groundwater contamination and development and water resource protection. So that with that few words, let me introduce Professor Ricardo Hirata, and we'll be very obliged to hear your talk. Thank you so much.
Thank you, Professor Mukherjee. And first of all, I'd like to thank the organizers and particularly Professor Vetri and my colleagues from the Professor Lee from the Chen Yang University for this kind invitation and allow me to talk about the groundwater, climate change, and cities. And I have a problem here to show my presentation, actually. Could you help me on this? Because I try to use share the screen, but in the share screen, I cannot see any alternative to show the presentation, my presentation.
Oh, sorry for that, Professor Hirata. Please, Simiso, can you guide here as how to solve these issues? Simiso?
Yes.
I try, so I try to share my screen to the audience, but I think that I can't because the program doesn't allow me to do that. I try to use.
When you click share screen, what happens, Prof? What do you see?
I saw four different icons. One is a beta icon. Another is part of the screen. Some sound from computer and content of my second camera.
All right. I think you need to open the presentation first before you share. Just go to your browser and look for your presentation there.
No, I can't. Okay, I see. It's not allowed me.
Okay.
Because
have you opened the document though? Is it open?
Yes. It's
all
open.
Right. Close that window, the sharing window. Let's start afresh.
Sorry, close to what?
Close the sharing. You started sharing screen, right?
I try to. Actually, now I cannot open my video, neither the screen, actually.
Okay, at the bottom there where you have icons, click on the zoom icon.
Where is the zoom icon? Sorry.
Right at the bottom, where your taskbar is.
I have two buttons. One is for sound, another is for video. But the video is not allowed me to. It asks that the host can permit me to open the video,
Okay.
not me.
Next to the video, do you have the share tray?
The share screen.
Yes.
The problem is that unfortunately my Zoom is in Portuguese. It means that it's a little bit different. I have to make sure that
you're clicking the right one.
Professor Hirata, just a suggestion. Is it possible maybe to email the presentation to Professor Ilmalai, and then he can share from his side, and then we can just, and he will move the slides, and then we can just have you presenting. Considering the issue of time. And maybe while he's doing that, Professor Mukherjee, maybe we can find out if our next speaker is ready, and then maybe we can proceed with him while we get the presentation emailed.
Yes, for me it's fine. I can do it. I tried to enter before the presentations, but I couldn't. I just saw the music and music presentations. I could not contact any people before this session. Sorry,
yeah, I
sorry
also
for
had
that.
the same experience.
Yeah,
I
sorry
think
for
just
that.
the technical world with that new kind of problems that we are facing. Sorry about that, Professor Hirata. Is Professor Jeming-Shi here?
Yes, can you hear me?
Yeah, we can hear you.
Okay.
Would you be ready to present if we can give?
Yes, I'm okay. Yeah, that's okay.
Okay, so maybe we can request you to present, and maybe we'll just wait for Professor Hirata to fix up the problems. Is that okay?
So can you see my screen?
Yes, we do. Could you make it
yeah,
full screen, please? Yeah. So let me introduce Professor Jeming-Shi. He is currently working at the School of Water Resources and Environment at the China University of Geoscience. His study mainly focuses on interaction of crustal deformation and groundwater dynamics of oil aquifer systems. He develops methods to obtain water hydraulic parameters by passive ways, and employs such methods to obtain continuously evolution of crustal permeability. So it's a very unique study. Like I think many of us would be very excited to hear from him, and because these studies provides a direct insight on the correlation between hydrogeologic processes and tectonic processes, which many of us would not readily see the connection. So I request Professor Shi to enlighten us with his work. Thank you, Professor Shi.
Oh, okay. Good morning, everyone. So and first, I would like to thank Professor Ilmalai and Professor Lee for providing this opportunity for me to share our studies with colleagues. Today, I'm going to talk about the aquifer system characterization by passive investigation method. As we know that characterization of the aquifer system is a fundamental task in the hydrogeology studies. Usually, we use active investigation methods such as pumping tests or slug tests. But today, I'm introduce a new techniques that use the passive investigation method. So my talk will follow in the 4 sessions. So first, as we know, the permeability or hydrologic conductivity in hydrogeologies, it determines how easily water can move through the rocks or sediments, which is highly dependent on the properties of soil and the rocks. And because of the different geologic histories, the permeability in different locations and different depths are always different. And such values may be varies from in tremendous ranges at the more than at the orders can be as large as 14 orders, for example. And for the aquifer and aquitides in the real world, they are not homogeneous and they are heterogeneous, which means that it will be changes very differently, even very closely. So it is required us that we need to understand what's the permeability in on the ground. So here's an example why we need to understand the permeability of on the ground. So from the upper panels of the figures, we can see that the groundwater is moving quickly in the in limestone aquifers, and the contaminants leakage from the spec tanks also moves quickly from along with the fractures. So such contaminated waters cannot be purified by the limestone aquifers, so it will be leached to the domestic wells. So when you pump water here, you will also will pump out the contaminated waters. But if, as we can see from the low panels, that groundwater moves slowly in the sandstone aquifers. So in these cases, groundwater moves slowly, and the contaminated waters will be purified before it arrived to the domestic wells. So in these cases, you will not pump out the contaminated water, and the water pumping out is clean. So this is tell us that the different aquifer hydrogeologic conductivities determine how fast the contaminants transport in the aquifers. So that's why we need to know exactly the properties of the permeability of the aquifers. In that way, we can understand better about the aquifer flow and the transport. So usually there are several popular ways in determining the aquifer permeabilities. The first one is the pumping test. So from pumping test, we usually need to pump in large amount of waters from the aquifers, and then cause the groundwater drawdowns. And here you need an observation well to record these drawdowns, and by using these drawdown data, you can get to the aquifer permeabilities or the aquifer hydrogeologic conductivities. But if this site is a contaminated site, that means you will also put pumping out a lot of contaminated waters. So how to treatment such a large amount of contaminated waters is also a very difficult thing. So the second way is that we usually to determine the aquifer permeability is that by the slag test. A slag test is that you use the BIOS or ALS to cause groundwater level changes instantly, and then you require this recording the process of the recovery, and you can use the recovery data to get to the also get to the aquifer permeabilities. But for the slag test, that it is very quickly, and you do not need to pump in a lot of water. But the problem is that because it's just cause small disturbance near the well bores, so the aquifer permeability you inferred from this method maybe only represent a small area of the around the wells. So the third method is that developed recently is the oscillatory pumping test. This pumping test is different with the first ones because this pumping test will cause periodically pumping rate. So when you can use this periodically pumping rates by solving the periodic analytic solutions, you can also get to the permeabilities. But for this method, as you can see that you need a very complex field instruments, and also you need several pump controls to produce the periodically changes. But this method is useful in the contaminated sites because you do not need to pumping out much of the waters. So here's a summary of the three methods, and all of the three methods are called the active ways, which means that the groundwater level changes are simulated by human. Thus, that means you need to do the field experiments to lead to the groundwater level changes. And also in such method, you cannot obtain the continuously hydrological conductivities. So in fact, there's another ways that we can determine the aquifer permeability or the hydraulic conductivities. That's the pathways. The pathway means that the groundwater levels are caused by the natural forces such as the earth tide, biometric pressures, rainfall, evapotranspiration, and so on. So among them, earth tide and biometric pressure are two most widely used natural forces. So first, the earth tide. For the earth tide, it is produced by the planets exert gravitation force on the Earth, and the tide force is not uniform. It is largest near the equator, but it decreases away from the equators. And because of the rotation of the planets, the tide force will also shows periodically changes. And in the solar systems, all bodies will exert tides on the Earth. But moon and the sun are the majority contribution to the Earth tides. So there are 4 majority tide, Earth tides that produced by the moon and sun. These 4 tidal waves are contributed to more than 95% of the Earth tides. And this tidal waves have periodics of half a day and nearly 1 day. And for the biometric pressures, this is the time series of the biometric pressures. And if we transform it into the frequency domain, we can find that the frequency components of the biometric pressure is much more complex, and the frequency band is much wider. And if we zoom in the frequency band that overlap with the Earth tide, we can also find two components that also included in the Earth tides. That's the K1 and S2 signals. And this is an example of 3 different time series. The red one is the Earth tides, and the black one is the biometric pressure, and this is the groundwater levels. So if we transform into the frequency domain, like in the right panels, we can see that the groundwater levels can record in the signals from the biometric pressures and also the earth tide signals. And if we see from the global scales, we can find that the earth tide and the biometric pressure can be found at global scales, which means that we can use this method to get that means that the groundwater on any location on the Earth can also recording the signal from the earth tide and the biometric pressures. So how we can use these signals to determine the hydrological conductivities or the permeabilities? That for the natural forces act on the aquifers, we can, if it is a confined aquifers, that if the natural force act on the Earth surface will make the deformation of the aquifer, that will lead to the groundwater flow between the wellbore and the aquifers. Because there's the groundwater flow in the aquifer need time, so there will be time difference between the natural force and the well water level responses. So we call this time difference phase shift. And for confined aquifers, so this time shift is negative, which means that water level response is linked to the tide force or the biometric pressure responses. And also we call the relation between the water level changes and to the natural force amplitude as the amplitude responses. And this is the case for the confined aquifer. But if the aquifer is not very well confined, there's vertical flows there's a waterfall ground flows, then the phase shift may be either positive or negative, which makes the situation more complex. So next we introduce how to use the response, the earth tide response to get the aquifer permeabilities. If the well is located in a well confined aquifers, then the groundwater level response will be lagged to the earth tide responses. Then we can use the phase shift to get the aquifer permeabilities and use the amplitude response to get the specific storages. And but if the well is not well confined and there's vertical groundwater flows, then we can use the tide leakage models, which considers the permeability of the aquifers and the permeability of the aquitides. And in this case, we can get a permeability from the aquifer and also from the aquitides. And for the biometric pressures, we have two ways to determine the aquifer permeabilities. One is in the frequency domain and another in the time domain. For the method in the frequency domain, we can find that the biometric pressure response in the frequency domain can be divided into three different frequency band. That's low, intermediate, and high frequency band, which corresponding to the process that biometric pressures across to the unsaturated zone and the confining layers and act on the aquifers, which cause the groundwater level flows in the aquifer and interaction between the borehole and the aquifers. So by fitting these theoretic type biometric response functions and with your observation data, you can get the aquifer permeabilities and also the vertical diffusivities in the aquifers. And yeah, this is one example that you can use the fitting by fitting this observation data, you can get the permeabilities. And the last one is the biometric response, pressure response method in the time domains. For the data in the time domains, that water level response to biometric pressure fractions can be expressed as a convolution as the forms like this. So in fact, this means that each groundwater level changes in response to individual pressure, atmosphere pressure changes. It's just can be regarded as a one slug test. So a series of groundwater level changes is just like a series of slug tests. When we superposition of this individual biometric response together, we can get the biometric response functions. And by these functions, we can also determine the aquifer permeabilities. So we applied this different method in one well. We've selected one well located in the southwest China. This well is located in a sandstone aquifers and overlaid by a shear. And this well has a depth of 251 meters. We collected biometric pressure and water level data from June 2008 to July 2009, and the sample rate of this data are 1 minute. So first we use the tidal response models. In order to use the tidal response models, we need to extract the phase shift from the groundwater levels, and we use the tidal analysis to get the phase shift, and we can get the time series of the phase shift. So from here, we can see that the phase shift of this well is around 22 to 25 degrees. So this is the phase shift is positive, which means that there may be existed vertical groundwaters as well as the horizontal groundwaters. So we use the tidal leakage models to get the aquifer permeabilities. And here we use the aquifer transitivities. The aquifer transitivities inferred from this waste is about 1.3 at the order of 10⁻⁶. And the second, we use the biometric pressure response method in the frequency domain. So one of the important steps is that you need to calculate the biometric pressure response in the frequency, how it changes with what's the relation with the gain, phase shift with the frequency changes. So after this can be done by using the transfer functions. You can solve the complex system of equations by the transfer functions. Then you can fitting these data with the theoretic biometric pressure response models, and you can get the aquifer transitivities. And for these wells, the transversity by this method is 2.9 also at the magnitude with orders of -6. And finally, we use the third way that the biometric pressure responses method in the time domains. And we calculated each individual biometric pressure responses, and then we get the accumulated biometric responses. And as we have mentioned about that, the biometric pressure responses can be regarded as a series of slug tests. So we put this biometric pressure response function into the slug test models. Here we choose the Cooper-Broad-Haft-Papa-Durs slug test models, and we can from this we can get to the aquifer transitivities of 9.5, also at the orders of -6. So finally, we put these three passive method results together and compare it with the traditional slug test, which we have conducted 10 years ago at these wells. And from the tables, we can find that all of the results are at the similar orders, at the orders of -6. And because we do not have conducted pumping tests in this well, so we cannot compare the result with pumping tests in these wells. But we have do a lot of other works that compare the pumping test result with the other passive methods, and they all fall in the same orders. So we think that our method is reliable and can be used to infer the aquifer permeabilities in many places. And finally, so we think that it is possible to image the aquifer system properties, that if enough wells are installed and monitored in the sites. And what's more, because this method are passive, so you do not need to do field experiments. You just need to monitor the data, and this is especially useful to monitor like in the area like the subsidence areas. But one thing should be noted that there's some requirement to use this method, that you need at least have 1 month observation, and also you should at least have 6 hours. The sample rate must be more than 6 hours. Okay, so sorry for the time delay, but that my talk is over. And if you have interested in these techniques, you can also read these papers that published by us in recently. Okay, thank you.
Thank you so much, Professor Shi. It's a very interesting presentation. I really loved it. And I would definitely like to know more from you on this. Maybe I'll email you, like we are actually working on a similar topic. So I'll definitely love to hear more from you. So meanwhile, can we ask a couple of questions, Vetri? How are you doing on time?
Please, you can go ahead, Prof.
Where do I get the questions? Maybe here. Yeah. Maybe you can ask. I'm not finding out what the questions are. Vetri?
Hello.
Yeah, can you please ask the questions, please?
Due to the time limit, I think, they already
Yeah, maybe
delay.
one question. Yeah, maybe one question.
Yeah. If any of our colleagues would like to ask question, if they can ask any question, we can go. Otherwise, we can skip the. Yes, I sent. I think no more question from the colleague, Prof. Mukherjee. Better we can go ahead.
Okay. Thank you so much, Vetri. And so I again appreciate Professor Shi's work, and I think people who work on the numerical domain, this is a very exciting talk. Thank you so much, Professor Shi, again. And
thank you.
Thank you. I'll be in touch with you.
Okay, thank you.
The next speaker we have in line, who was again our second speaker, but because of technical difficulties, we had to skip. So, Professor Hirata, are you good now, Professor Hirata?
I have sent to the Vetri's email my presentation.
Okay.
So did you receive it, Vetri?
Professor Hirata, that's why I text a message and send an email back to you. I received your email, but I couldn't download that your presentation because I need to get your access to download it. If you give the access, then I can download it immediately. But in meantime, Professor Abhijit, we can move to other session because already we delayed. When the Professor presentation he accessed for my request, then I can join.
Okay. Thank you so much, Vetri. So I suppose my job is done. And it's a wonderful wonderful experience to be here, and I really really happy for being invited for this session. Thank you so much.
Thank you so much, Professor Abhijit. I think Ms. Chuli can continue with the next session.
Okay, thank you, Professor Mukherjee and Professor Elmalai for chairing our previous session. We are now going to proceed into session 5, which is environmental geology and climate change. And this next session is going to be chaired by Professor Siepe, Deputy Vice Chancellor of Institutional Planning at the University of Zululand, together with Dr. Brian Chase, who's the professor at the University of Montpellier in France. Without wasting any further time, I'd like to hand over to you, Professor Siepe. Thank you.
Colleagues, good morning. Can you hear me?
Yes, you're audible. We can hear you.
Okay, so you'll have to make possible for me to access the video. But without much ado, may I proceed with this session by calling the first speaker. What is going to happen here, because my colleague Dr. Chase is going to be speaking in the next session, I would do the honor of introducing the first speaker and him and the third one, and he'll take after that. Our guest speaker, our next speaker is Professor Ramanathan, and whose area of interest is in environmental geology. And among other things is that he brings a vast experience in this, having occupied this position or being in this area of research for the last 35 years. But I thought what was most striking was his notable achievement that he has been listed as one of the top 2% of global scientists from India in environmental engineering. He has promoted quite a number of students, 33 PhDs, 15 Ms, MPhils, and 41 MScs. So what we have here, ladies and gentlemen, is somebody who is not only a teacher, but a researcher of note. And he'll be taking us through his presentation. And without much ado, can I call Professor Ramanathan to take the stage.
Okay, good afternoon, Professor. Thank you. My video is off. I don't know. I cannot. Thank you for this. I cannot start. I can present my. Can you able to see that?
Yes, we can see your slides.
Yeah. Thank you very much, Professor. Thank you for the opportunity for Vetri Murugan and the University of Zulu, and I'll be concentrating more on the waters and from the glaciers and water resources. That also we are working along with the environmental geosciences. So this is the glacials are supposed to be the perennial ice features that temporarily stored fresh water at higher altitudes. The loss of these mountain glaciers, that is mass loss, is very important for this because millions of people are depending on this glacier ice and snow. And there is a critical link in the fate of glacier and sustainability of water resources. And then supply and over exploitation is also there. Nowadays, glaciers are also vanishing in Iceland and other regions. They are also having museums to know that the glaciers are vanishing. The mountain topography, because basically mountains say either eco-hydrology or the glaciers. Both of them are going to help us to nurture the water resources from modifying the climate required for sustainable glaciers to influence all surface, subsurface, because the springs are the indicators of the health of the mountain ecosystem, especially eco-hydrology. So that is also indicators. Glaciers are now the effective water towards accumulating the seasonal snow and ice. Water flowing from the mountain is often utilized for hydroelectric. This is also very important green energy. And nevertheless, human demands of water is regionally impacting this water resource nowadays. So the glaciers are considered as a natural climate meter. So if there is vanishing, that is, we are very clear that we are losing the mass because of the rise in temperature, atmospheric temperature, and the sea surface temperature. These are the indicators. So glacier has to be healthy, whether it is in the Arctic, Antarctic, or in the mountain regions of Alps or Himalayas. The widespread glacier imbalance was observed globally, including in the high mountains. And then if all these ice melts, excluding the ice sheets, the sea level will rise by 87 meter. That is what IPCC's prediction, 87 millimeter. So other local regional consequences are wide. Regional water resources and livelihood is important. Hazards like glacial lake outburst floods are happening in this, and avalanches are happening. Irrigation problems are because of this, and tourism. And the continental scale, that is the sea level rise, and the global conveyor beltism, because the sea ice are melting, then the sea surface temperature increasing, then your ocean current will not be transporting the nutrients and the temperatures. And high free ice will lower the earth albedo. That is also a problem in this region. So this is the approach we generally make. That is, one is the glacier length and area. We have to study whether it is Arctic, Antarctic, or the mountain glaciers, Alps glaciers, the glacier mass and energy balance, which is going to tell us about the short wave, long wave, and the wind speed and albedo changes. And then ultimately everything we are studying for the water resources of this region. So this is the one of the important slide that we are looking into that. You can see that one, the health of the glaciers, because if you see that the mass we are losing, ice mass we are losing is more in this region, Alaska, and this region of this year, because and the next one is coming to this region in this area of Himalayas, and then finally, and the best one is in the region of Karakoram. So these are all affected in these regions, which shows that the mountain glaciers are relatively healthy compared to the maritime glaciers, because the sea surface temperature is increasing, and then that is affecting the and melting them. That is what Antarctica, especially the western Antarctica and the Arctic regions, they are all melting, and they're losing a lot of mass in this one. You can see that one, 3000 gigaton in this region, and this region is 1200. And then the Canada, they are losing thousands. So here it will be relatively less compared to that one. Russia, we are losing 1,000. So the glacial observation starts from 1970s from the Europeans and other things. And there are actually the World Glacier Monitoring Surveys by ZEMP, who is leading that, he has published. Since then, the glaciers melt has contributed 27 plus or minus 22 millimeter of the sea level rise. The highly negative mass balance rate, Alaska, Southern Andes, Western Australia, and the recent global mass rates at minus 0.448 meter water equivalent per year. We are losing this. This is really alarming situations in this region. So here the total loss we are losing, we are losing is around 1 trillion, is the 3.8 trillion in this northern hemisphere, plus Arctic combined together, we are losing around 12 trillion tons. Whereas in the Antarctic also similarly we are losing it. Whereas in the mountain glaciers we are losing relatively less. That shows that maritime glaciers are. This is the recent paper by the Slater from the US. They have developed a lot of them and then find out the estimation, the volume very accurately. And then the Earth has lost around 28 trillion tons of ice since 1994, and about 34 millimeter they contributed the sea level rise. Even though it is like for example, South Africa is not near to that, but the sea level will affect them and the climate will affect them by teleconnections in these regions. Losses of Antarctica and Greenland ice sheets have accelerated, and then due to the worst climate scenario in this climate, and sea level rise and the communities, coastal communities and the natural habitats will be like mangroves and other things will be getting stunted in the future. So you see here that high mountain Asia plus the Himalaya, you see the Tibet and then Karakoram and all those things. You feel that the Karakoram and all, even though there is slightly negative, is that Karakoram is positive. So overall, if you see that when compared to the global glaciers, that Himalaya, that is mountain glaciers, high mountain Asia and then Himalayas will be losing less mass in this region. And then here itself, the billions of people are depending on this. Around 17 countries are depending on these water resources in this region. And then the corresponding to about 4 to 6% of global sea level rise and the high mountain Asia. High negative positive mass balance in eastern Himalaya, that is Karakoram is there in that western Himalaya, sorry, that is it is written eastern. As per the Geological Society of India, we have this basins like Yellow River, Yantis, Brahmaputra, Irrawaddy, Ganges, Indus, Amulya. So the river basins are also around 12 river basins are there in this. The total Himalayan, because I have been working on this Himalayan glaciers from these western Himalayas. So I am just concentrating. I gave the overall picture of the globally what is that maritime glaciers and the alpine glaciers. And this is the, because this is the westerly dominated, and then we have the Indian summer monsoon dominated moisture sources, and then the Asian monsoon dominated. We have a lot of populations, and then snow melt is very important for socio-economic and agricultural activities, and then hydroelectric power in these regions. So this is the blue is the glaciers. So we have more than 30-40,000 glaciers, but we are monitoring in India only out of 10,000 some 7-8 glaciers. So these are the climatic scenery of Indian Himalaya. So we are getting largely controlled by the winter accumulation, 84 influx through the winter, whereas in the central Himalaya where the Gangotri and our Chota Shigiri is there, and where we are working, we can see that within that several rivers are here. And then here it is Indian summer monsoon is contributing. Here it is monsoon is 50%, 85% of the westerly disturbances in these regions. So why the glaciers and the Himalayan high mountain Asias are important in Indian context, if you see that one. So even though we have the perennial peninsular rivers like Godavari, Krishna from the Western Ghats and Eastern Ghats, so their potential is relatively less compared to that of the Himalayan glaciers. That potential is very water resource, but utility is also estimated utility results are very high in this region. So especially during the summer, we need to have these water resources in this glacier input regions. So you see the differences between this peninsular and this rivers. So here we should have a water resource management, watershed management to recharge the groundwater. Here, along with that, we should have this glacier health also in this region. So this is how you can see that the population 2015, you see it's a lot of populations are there in this region. That we are having around 5 lakh people living in this every square kilometers in this region. And then we have a lot of irrigation barrages, hydroelectric plants, hydropowers. So it is a larger potential in these regions, and we have the produce up to 500 to 7,000 megawatt of electricity can be produced potential. And some of them are under planning now. Some of them are implemented in these regions. So how important are these glaciers is that, so you can see that during the normal year, it is contribute only that it is contributing very less, remaining are all precipitations. 80% is contributed by this precipitation, remaining will be melt filter of the snow and the ice. When it comes to the drought here, you see that one, that dark blue is increasing everywhere. So that means that from the 20% to 70% in the Amulia Basin, in the RL in this region, the fire and all, you will get a lot of 70% depend upon the melt in this region. So here you see that one, this is very less because these are all controlled by the Indus basins, and other things are controlled by this meltwaters, especially due to the drought here in these regions. So drought is resilience is only when the health of the glaciers is very good in this region. So here if you see that one, that runoff and the glacier contributions. So you can see that the contribution goes from 0 to 2% to 81 in the recent papers, 81 to 100% is contributed by this glacial melt. And then the runoff is also depend upon this region. So the maximum runoff is the combination of the Indian summer monsoon and the meltwaters. The glaciers from the Sikkim regions contributing to this, and then Tibetan regions contribute to the Sangpo River, and then comes to that Brahmaputra in these regions. So it is very important to so it is having a lot of utility for the agriculture, hydropower, and then climate change impact is impacting them very. And then we also do some detailed studies of the individual glaciers, and we try to understand that how important is the snowfall by the correlations. For the snowfall, if you see that they directly control the mass balance of the glaciers, and also the total cloud cover and the albedo of these regions, because the albedo is going to be affected if the glaciers are losing the mass. If the albedo is more, that means more melting of this glacier, either it is continental glaciers like your Arctic, Antarctic. So there is a snowfall variability, even though it is happening in the timing of the snowfall is very important, which explains that 60% of the mass balance variability, that is 0.2 meter per year, implying the significant sensitivity of the mass balance of the snowfall. The high sensitivity of the mass balance of snowfall offers crucial insight to the mechanism of the recent glacial response to the Hindu Kush, Karakoram Himalayas. So these are the glaciers we have been working in these regions. So that is in the Stock and these regions in this Leh Ladakh. And then we are Chota Shigri and Patsho Glacier, Panchi in these regions. And then in the Sikkim, we are working on the Onglatang glaciers. In order to get the micro meteorological impact on this and the orographic control, how they are behaving, this is our ultimately the outcome we are expecting after our studies. This is a robust data set we want to create it so that the Himalayan glacier health can be understood properly. So these are the characteristics of these glaciers. That is what we are working. We are doing mass balance, energy balance, hydrology, isotope hydrology, surface velocity, hydrochemistry, etc. And they are all from smaller to bigger glaciers, and then we will do the surface velocity. So we cover most of the regions because of the PhD students are there. That's why we are able to do that. And then this is how we do the mass balance, winter and summer mass balance. Earlier we could not do it because of the logistic and funding problem. Then now we are doing it winter and summer mass balance. You see that one, we have the positive mass balance years, and now again from 2019 we are getting slightly positive. And then in our small glacier, Chota Shigri Glacier, I told you this is a small glacier. What we are doing is that in this region, this is the glacier we are working. So here we are monitoring from 2002 until even 2019. So we lost around 0.46 of these individual glaciers. But overall, we are losing only 0.9 in the Himalaya in these regions. And but similar global estimate is also 0.48 overall in these regions. And there is a change in the cycle between the positive and negative. And then the resilience capability of the glacier is estimating to be around 30 to 40 years. And similarly, I want to tell you that I told you that impact of this precipitation. The timing of the precipitation is very important. If it happens in the April, August and April, then it will be having the impact on the positive. Albedo will be increasing in this one. If it is at the end of the month, it is happening, then it will not have the impact on this. So the timing of the ablation period, how much is the snowfall is occurring. So if the timing is good, then we will be getting around that is positive mass balance. If it is happening at the end of the season's ablation season, then it will be negative mass balance in this region. So the snowfall also, anyhow, winter is very important, but summer is also very important. That's what our studies highlight, which controls the albedo and the health of the glaciers in these regions. So similarly, we try to understand the hypsometric elevation-wise changes in that one. Generally, the elevation is supposed to be controlling that one. Another glacier we are studying. Actually, it has to be from the lower elevation, it has to be thick red, and then it has to be blue. But there's a lot of mass that will be lost, and then addition of mass will be there. But if you see that one, there is not a changing linearly. That means that hypsometric changes, elevation-wise, because of the orographic control, the health exposure of this and the albedo changes with respect to that in these regions. The mean glacier-wide mass balance is about 0.53 from 2017. This is what the Paksho Glacier we are doing. Large variation apply. This is the altitudinal variation is very important because of the orography compared to the continental glaciers in the Himalayas. This is what our findings show that. And along with the winter precipitation, the amount of precipitation happen in the summer is playing a major role in these regions. So similarly, we try to find out that now how this glacier size is impacting and the debris cover impacting the hydrological system. But most of the system, if you see that the ranges run off from the 5 to 10 meter cube throughout the ablation period. So we try to model it and then we are trying to project it in the future. So most of the model results and these observed data are correlating well with each other except 1 or 2 years. And we are now working on this out from the models as well as the isotope studies to distinguish the amount of melt coming from the glacier, snow melt and total runoff. And also we are trying to understand the dead ice, that is subsurface groundwater flow in that one, which is very important because ultimately the glacier melt is very important. Glacier melt has to be reduced and only peak during the ablation period. If the glacial melt is increasing, that means the health of the glacier is not good in this region. Snow melt has to be increasing and then decreasing, but not the glacial melt. That's what we're working on that. And also we try to understand that how this elevation is controlling the mass balance in this region because the temperature is increasing in the region. But you see these elevations in this Nepal study, they are showing that with respect to the elevation, depend upon the exposure of this albedo changes in this region. Within the medium elevations, between the 4,000 to 5,000 meters, you will get a lot of discharge. Meltwater contribution is more. That means the glacier are, because this area is exposed to the sunlight and then there is not having debris cover, here debris cover, and then here the temperature is low because high elevations. So the elevation is controlling that amount of water and the melting in these regions. So the Himalayas are having that lot of, because not only the water, because we are also depending upon the sediment. Lot of sediment suspended load is coming and the global sediment flux is more in this Himalayan regions. And this Ganges, Brahmaputra and El River carried 3 gigaton per year, 25% of the total sediment into the ocean. This is very important for the productivity of the floodplains as well as the deltas and then the coastal area. So it all depends upon the steep slopes, high erodibility, high elevation, and intensive agriculture and urbanization and forest. And recently, because of this, if you see the difference between the 1980s and the post-1990s, you see the difference in the sediment increase. In the erosion rate is increasing because of the deforestations in these regions. So the Ganges and Brahmaputra, you see there is a sudden shoot up in this and sudden shoot up in the regions of this sediment load in the area. Overall, the past decades of the rivers has dramatically changed in the water discharge and the sediment flux. For example, Ganges, you see that is Indus and everything is increasing in the region. Dam constructions and water diversions are also happening in these regions, and that is also reducing the sediment load in some of them, and also nutrient transport from the upstream to the downstream. And then the soil conservation, climate and glacier melt and sand extraction is also another important problem here. So these sediments are, along with the water, dissolved nutrients. They are also important for the glacier melt runoff is likely to be an important source of the nutrients. And then we call it as a glacier floor, which is highly productive, which is, that's why in the upstream regions of these regions, we get a lot of nutrients from them. And then the criconites, which is also supplying the nutrients, and the microbes living on the glaciers play a crucial role in cycling the nutrients for the carbon, nitrogen, and phosphorus. So this is very important. That's what our preliminary study indicates. Wherever there's a more clay and silt, there is having more nutrient in the glacial sediments in the regions. So this is the glacial floor that's what I told is very important biomineralizations. And then they are having that rock floor is very important for the productivity of the soil. And then they have the capacity to neutralize the soil acidity, a continuous supply of both macro and macronutrients, and then trace minerals and trace metals, increase the soil retention, especially when the clay is there in that region. So we are also working on this to find out how this transformation is taking place, and then agricultural productivity is working on this. And this is also controlling the bioalbedo. That is very important, because the albedo, as I talked to you earlier, that the albedo, because of the vanishing of the glaciers, the albedo is increasing. Nowadays, the black carbon is also there, that is also increasing. Besides that, the microbes, they are also having, at least in Antarctica, they found out that 5% of the albedo is controlled by this criconites. They absorb the solar radiations. And then these systems are having the very important the biogeochemical reactions and for the nutrient supply for the microbial community. And then the criconite holes have the potential to fix as much as 64 grams of carbon. So either that will be make it as a neutral or negative carbon, negative. The glaciers are healthy, that is very good. And then they contains about 70% of the fresh water in the planet, and they are all autotrophic. They produce their own nutrients in this region. This is how the principle works for this albedo. So another one is that black carbon. Black carbon, because of this, nowadays a lot of problem in the black carbon. So you see that one. So 14% of the Arctic warming and 24% of the Arctic snow and ice loss is due to the black carbon albedo. And in the regions of Western US, you'll be getting that impurities led to 66% of the albedo reduction in Alaska in the region. That is not good for that. And then increase in the discharge is happening in these regions. Similarly, the snow cover duration also reducing nowadays in this Tibet. And in the Himalayan glaciers, only 1 or 2 studies are there. We need to do a lot of studies in that one. And in the Alps, we are getting the glacier mass balance reduced by 280 to 480 millimeter water equivalent, resulting in the discharge. Discharge is increasing. So discharge is increasing. It shows that not only the snow is melting, ice is also melting, which is not good. As that's what we are working on that to find out how much is the glacier ice is melting, how long it is going to sustain. If the glacier ice is melting, that means it's going to vanish at a faster rate. So the impact of the dust and black carbon, other polluting agents are less studied in the mountain glaciers. So especially in the Himalayas, and black carbon dust are the short-lived climate forcers. But it is very strong impact is there. Ice records increase, shows that increase from 1850s, and it is continuously increasing. That means the human anthropogenic activities, especially near to that glaciers, especially Alps and other Greenland and other areas, Scandinavian countries, the activities near to the glaciers are going to impact and reduce the 20% of the snow ice albedo. And then the major source of fossil fuel is also, that is, we are using a lot of fossil fuels and biomass burning, that is also impacting in these regions. So this is how this impact is happening in this. And then like our rainwater harvesting, recharging and the check dams, we also try to do, now we are working on this Ladakh region with some collaborators from the local area as well as from the UK. So this is especially Ladakh region, which is all depend upon the snow melt, as I told you, in the Western Himalayas. They are having the less solid precipitation in the winter because they are feeling that the temperature is rising in the Western Himalaya. That's why the climate change. And no sufficient water during the early crucial cropping period. So the snow and glacier melt, sufficient water during the midsummer, but not, and end of the summer water is wasted because no agricultural activity. So new initiative tackle that we are trying to work with. Already it is, the concept is there, but we are going to work with them to identify a lot of zones, microclimatic zones, to put the artificial glacier and ice to pass. So this is how these artificial glaciers are put in this. 2 things they do it. The first conceptual implemented by the Padma Shri Norpal, and they consider in the Shadier Valley. But only thing is that it's having a lot of surface area, hence the melting is too much in this region. And it can store good amount of ice, but large surface area. And then the expensive and laborious in this region. So this is how it started, harvesting. Now we are all working on this, only the stupas, because it is very important, because it is having higher elevation. These microclimatic zones we have to identify in each villages. And then the this is concepted by Mr. Sonam Wangchuk, and it can store good amount of ice, but lesser than the artificial ice, but melting is more in artificial glaciers. But here melting is less because surface area is less. So ISURB has created great awareness among the people. Now we are working with them to identify more locations, microclimatic locations. But it is extremely expensive, but it is but laborious, but it requires a lot of expertise to build this. Inside there is a bamboos are kept, and over it ice mass will be sprayed by the gravity, and then they will be forming the ice because of the low temperature in the regions. And this is how the glacier mass changes are driven. The glacier changes are heterogeneous. Like I told you, Karakoram, it is positive, and in the eastern part of the Himalaya, it is negative. Globally and regionally, where maritime is negative, continental is positive. Overall, the near surface temperature rise, 0.2 to 0.1, is the primary cause of the pronounced glacial melt, but it varies. For example, in the high mountain Asia and Himalaya, surface air temperature has warmed slightly higher at 0.3 to 0.2 degree per decade globally. The most uncertain but crucial is high mountain precipitation, which remains uncertain due to lack of measurements, particularly snowfall data in these regions. So precipitation data is very lacking in these regions. Only modeling we are doing, but a lot of error is there. And measurements also not possible throughout the glaciers. Another crucial impact, the surface albedo reduction is done by the dust, black carbon, and other polluting agents, particularly the Arctic Alps and high mountain Asia. Most studies conclude that near surface temperature and precipitation fluctuation the prime causes at regional glacier loss in these regions. So this is what I want to discuss in this. Thank you for your attention. Please.
Thank you very much, Professor.
Yes.
Are there any questions that the professor would want to engage? And if so, please feel free to ask.
Hello.
Yeah, hi, we can hear you. Go ahead.
I'm Dr. Chidambaram. I just have a small clarification, just out of the experience which Professor Ramanathan has and the vast experience on working on glaciers. I would like to have just two clarifications from his side, like regarding the melting of these glaciers. Sir, would you like to comment on the rate of melting of the glaciers, like whether in Indian scenario it is more, or in the rest of the part it is more, the rest of the part of the globe it is more? That is one question. And the second one is like, do you think that this melting of glaciers, they attribute different factors for that? And do you think whether this Hadley cell circulation will be a problem, or the astronomical forcing, or any anthropogenic influence like land use change, which is adjacent to the glacial, play an important role to cause the melting of glaciers? I just have these two questions. Out of your experience, can you just enlighten us with these points?
Yes, thank you, Professor Chidambaram. And one thing, as I told you, that maritime glaciers, because the sea surface temperature is increasing, like in Arctic, Antarctic, and Greenland. When the sea surface temperature is increasing, they will be having this calving effect. They melt it, they transfer the heat to the glacier directly. So most of the glaciers we lose in the maritime glaciers. And wherever there's a clean glaciers, we have clean glaciers and debris glaciers, even in the mountain glaciers like high mountain Asia, Himalaya, Alps, Cascadian mountains. So when there is a clean glaciers, when the clean glaciers are exposed, because they are, that's what I told you, it is sensitive to climate change. It depends upon the precipitation, that is solid precipitation, and the temperature changes in the area. So the precipitation is, if it is reduced because of this climate change, and the temperature, we have seen that 1.2 degrees are increasing in the Western Himalayas. So if it is a clean glacier, directly the snow will melt faster, and it will not be converted into fern and ice. That is a big problem. If there is having some debris covers, if it is thicker than 2 centimeter and all, then it will act as a isolation, that is insulation effect. Then it will all melt. So the individual glaciers and also their orientation, whether it is exposed to east most of the time, eastern side orientation, they will melt faster than the glacier which is exposed to the northern side. So that is the one thing. And then this glacial response time is around 30 to 40 years, sometimes 100 years. So Hadley cells and this climate change impact will be having an impact for a shorter durations. But the climate change, like effect will be more in that region, because if it is more than 30 years, the glacial response will be generally 40 to 100 years to come back to that equilibrium, from the negative to equilibrium. So, but man's impact, like rise in temperature and black carbon, when the black body is there, that will absorb more heat and melt. So this is what happening in this most of these glaciers adjacent to the land, when the land cover is changing, biomass is burning, like agricultural waste is burning and then going to by suspended material, it reaches the elevation of 6,000 to 8,000 meters. It is also having an impact on this thing. I hope I tried to.
Sir. Thank you. Nice. Yeah, it was very interesting. Thank you.
Is there any other question to Professor Ramanathan? In the absence of other questions, I'm sure colleagues, you have the chat room. We can exchange emails and probably follow up the speakers.
Yes,
right
sir.
now, I would like to thank him very much for a comprehensive presentations and the research that has gone into it, and also for honoring us by coming to this conference. Thank you very much, Professor.
Thank you. Thank you,
Professor. At this point in time, I would like to call my co-chair, Dr. Chase.
Indeed.
Dr. Chase is a paleoclimatologist, and he's also an honorary professor at the University of Cape Town, but he's based at the University of Montpellier in France. His research interest focuses on the study of past environmental change in the arid to humid environments of Southern Africa. Among other things, Dr. Chase is also a vice president of the International Union of Quaternary Research.
All right. Thank you very much for the introduction, and thank you very much for the organizers. Can you see my slides?
Yes, we can.
Okay, perfect. I'll just swing off then.
Sorry, Prof, we can't see your face.
Okay, you can see it. Great. Okay, right. So this is falling into that completely different category based on all the lovely talks we've heard this morning. This is about past change and more of a heritage perspective on how we study climate change, in this case, and specifically in the drylands of Southern Africa. Just to start very broadly, this is the world. And if you are interested in reconstructing climate and environmental change in, say, the white zone at the top there, you take your tractor, you drive across Greenland, you get out your core, and you get a beautiful, lovely ice core like this, from which you can reconstruct the kind of records that we're used to seeing when we talk about abrupt climate change, when we talk about the last glacial period. And this is all well and good, but you will notice that, but in fact, there isn't that much of this white area. There's some on the top and there's some on the bottom, but there's a whole lot in the middle. Most of us tend to live in these kind of greenish areas where there's a bit more water. And that works out pretty well if you want to understand what happened in the past, because you can get a raft and go out on a lake, which a bunch of people, or hire some old men to go out onto a bog in the mountains. And from these cores, you can look at the fossil pollen that's preserved within the sediments. You can look at the diatoms, the silica bodies that the algae form. And from all of these, you can date these sediment sequences, and you can reconstruct on the top here past vegetation, and on the bottom lake level changes, and get these lovely continuous records from these green parts of the world that you can link together, that you can use to understand how changes in certain regions relate to changes globally. Now, the problem is that there's also all this brown part of the world, which also many of us happen to live in. And Southern Africa is one of the notable ones. This is actually in the austral summer, so it looks a little bit greener than it would in the winter. But in fact, many of you who live in Southern Africa know that there are a lot of brown bits around where you're looking at different kinds of sand, essentially sand or silt or clays. And there aren't lakes and there aren't glaciers. And there are very few ways that we can reconstruct what has happened in terms of climate change in the past, and therefore understand how the system is likely to react to changes in temperature that we're seeing currently and potentially in the future as well, of course. This is the kind of record that we've traditionally gotten from these areas. These vague inferences about kind of wetter or drier periods across time. This is the timescales on the right there. This is the last 10,000 years, the current interglacial period, the Holocene. And you can see that it's hard to draw much from this. And so one of the questions that's been driving my research for quite a while now is in African drylands, where can we go for reliable high resolution records of change? And actually, it was the French, Amand Pons and Pierre Kizel, who first started down this path in the 50s. And they found little middens, little piles of excrement that were left by these critters that live in the Sahara, that in South Africa we know as dussies, there they know as damons. The issue is that they wrote it in French and they published in a journal that not many people read. And so it more or less went unnoticed. And it wasn't until the 70s and 80s when the Americans started to explore and exploit these deposits that they found in their desert regions. Now, these are left by pack rats. And these little animals, they go out and they collect nuts and seeds and sticks, and they build nests. And then what they essentially do is they wet their beds over the period of generations and a couple hundred years. And these nests turn into these rather disgusting looking deposits. Now, while they may be disgusting looking, they're actually, they have incredible potential for understanding past vegetation change. Because you can see here, these are all pine needles that are encased in this fossilized urine. And you can date these individually, you can identify them to species level, and you can say with some assuredness, this plant lived here at this time. Now, when you go and you collect a bunch of these things from all over the desert region, you can start to create continuous records of change. And you can say, well, you know, 10,000 years ago, 12,000 years ago, at the beginning of the Holocene, you had a much cooler environment with sort of alpine trees. And that as the climate warmed across this last interglacial period, the vegetation changed substantially. Now, this is fantastic, but pack rats don't grow or don't live everywhere. But Louis Scott, who's a recently retired professor at Bloemfontein at the University of the Free State, he was doing a postdoc in the States at this time in the 80s when all this work was going on. And he started to think about these similar deposits that he'd seen in his native South Africa. So when he came back, he decided to start looking at these. Now, as I said, these aren't created by pack rats. These are created by dussies, or Procavia capensis in this case. And these furry little guys live all over Southern Africa. They don't really care about how dry it is or how wet it is so much. What they really need is shelter. Because they get eaten by leopards and eagles and all sorts of things. So as long as they're sheltered, they can live places like this where there's very little water, but nothing can eat them, or they have somewhere to hide at least. Now, of course, as they do this, as anything lives where it lives, they have to use the toilet, shall we say. And they have this peculiar habit of defecating in the same spot for generations and generations and thousands of years. And they create these things that we call hyrax middens. Now, this is fantastic because they're similar to the pack rat nest, and you can use them in vaguely similar ways, which I'll show. But one of the problems is that they also tend to, again, hide from leopards, so go up on cliffs. They can climb incredible heights. And so you find these things often in difficult to access places. The work that we've been doing is more or less throwing ourselves off of cliffs to get at these things, to employ a range of power tools and wear lots of protective gear, because indeed, as long as you don't mind getting very dirty, and that is all urine dust that you see, which is not a concept that most people are familiar with most of the time, you can turn something like this on the left, a 2-meter pile of urine, into a nice sequence that you can then subsample and recreate or reconstruct past climates and environments. And these span thousands of years. This 75 centimeter section here is 28,000 years of continuous accumulation. And so keep in mind that this is different from the American and Australian ones indeed, where you're talking about a nest that is built and then preserved. This on the right, you can see is just 2 centimeters here, and you can see the very fine laminae. This is continuous accumulation, and you can get pollen and phytoliths and microcharcoal and stable isotopes, all sorts of things from each sample to reconstruct past environments. So quickly, looking at Durif down in the Southwestern Cape as a case study, we went and we sampled this and we got a record, subsampled it for the stable isotope content in this case. And we were very intrigued by this. And just to quickly get at what this means, on the right here, you have delta 13C, and on the left, you have delta 15N, 2 stable isotopes. And the delta 13C in this case is responding primarily to plant available water. And here you've got, with lots of plant available water under wetter conditions, you have lower delta 13C values. So delta 13C values go up as you have less and less water. So it's a reasonable proxy for aridity. Now, this is the same as delta 15N. In fact, there's more noise in both of these, but the same general pattern exists. Under drier conditions, you get higher values. So now we can apply an interpretation to these records that we have, and we can say that these, these lower values of delta 13C and delta 15N, that's increased moisture availability. And this is decreased. So we have wetter conditions up, drier conditions down, which is pretty much the way all my graphs work. So we compared this with marine core from the Benguela Current and looked at sea surface temperatures and found there's a very strong correlation between the delta 15N, which is what we'll focus on generally in this talk, and the sea surface temperatures, suggesting that we aren't looking at just some local anomaly, that this indeed reflects regional changes in climate conditions and circulation systems. More interestingly even, was that this big dry event that we identify in our record actually corresponds precisely with the Younger Dryas, the YD is an acronym, Younger Dryas, which is a cold event that's been observed in Greenland records. So not only do we have a regional understanding, but we actually have plugging this into patterns of global change, and we can see what mechanisms are likely driving what we're observing. Right. So just very quickly, a couple of super quick case studies here is, this is Southern Africa. And the take-home picture is that you've got this red zone and you've got this blue zone. And the red is basically, it's the summer rainfall zone. And it's where convective systems, tropical systems bring most of the moisture, most of the rainfall that falls in these regions. Conversely, you have this purple area, which if you live in Cape Town, you'll know you get all your rainfall in the winter. And you get your rainfall in the winter because as sea ice expands, as the westerly storm tracks, which kind of ride along this subtropical front, as that moves north seasonally, frontal systems come in closer contact and influence the Southwestern Cape, not the rest of the region so much. So this basic idea, and particularly during the last glacial maximum, this was much further north than it is even during current winters. That over time, the question has been posed, are cooler glacial periods wetter in Southern Africa's winter rainfall zone? So to look at this, we went to Sewevieksport, which is a nice midden site. And just very quickly, we compared it with the Holocene. And this has been inverted. So actually warm is down and cold is up. But you can see also a strong relationship here between increased moisture availability and reduced mean annual temperature, supporting this idea that cooler conditions equate to wetter conditions. Further afield and tying it in more to the westerly storm tracks, way over here in Chile, there's a record that they've interpreted as indicating the position of the westerlies. And again, here we have increased moisture availability at Sewevieksport when the westerlies are further north, linking again to mechanism and this idea that cooler conditions, extended sea ice, would bring more rainfall to the region. Looking directly at sea ice extent, we see also that there is a strong relationship between increased sea ice extent and increased moisture availability. In fact, this extends back over the last 25,000 years, like looking at the SOVIXPOR record, and a new record from Popkveilsfontein, a bit further west from SOVIXPOR, suggests that this extends back over the last 70,000 years. So what we can say about the winter rainfall zone based on these new Hyrax midden data, this Dusy midden data, is that cooler conditions do generally relate to increased humidity, not everywhere, I haven't shown everything, and that the last glacial maximum was much wetter than the Holocene. And there does seem to be a mechanistic link between sea ice, the westerlies, and rainfall in the region. Now, conversely, are warmer interglacial periods wetter in the summer rainfall zone? Indeed, convective potential being increased under warmer conditions, this would be expected to be the case. And it generally is. This reconstruction is based on some pollen from a series of records. And it shows that there is increased precipitation under elevated temperatures across the last about 50,000 years at least. So this is great, but it's not comprehensive. Again, that's from sort of these wetter areas. But what about the Namib Desert? Looking at this, we've collected a series of records from Spitzkop, from Zizu, and from Pella, and combining them all together, we've created a composite record spanning the Namib that is high resolution, well resolved, and presents a continuous coherent sequence. So from this, one of the things is that, if you cast your mind back to those black and white blocks that I showed earlier, how we reconstruct dryland climate, these blue zones are the wet zones that have been identified using those basic techniques. And it fits relatively well, obviously with much more detail. And it allows us to look at some questions like, how does orbital forcing affect the region, particularly precession? Marine core here, from off the Benguela, excuse me, from the Benguela system off the west coast, has been used to infer that there's a strong positive relationship between insolation, summer insolation, and precipitation. So with more solar energy during the summer months, there's more convection, there's more rainfall, you have wetter conditions. Now, that's all well and good, except that it's not what we see from the Namib Desert. What we see, obviously there's some noise, but the red line is summer insolation and the yellow line is our moisture. So we actually have wetter conditions when there's less insolation and drier conditions when there's more. This was a bit perplexing until you start to think about the region in a more synthetic, synoptic sense, and think about that these increases in insolation result in low pressure over the continent, but there's cooling related to these on the global scale that results in higher pressure over the ocean. And what this does is this draws all this dry, cold air into the continent and actually dries out the western margin of southern Africa and creates this dipole between eastern and western regions. This is really important when you're thinking about long-term climate change and how this might, how these different drivers will impact the region. We actually see this played out on the long term here, where the yellow is the Namib and the red is the northern summer rainfall zone. And you can see this more or less a negative relationship between the two across this period. What's also interesting is how rapidly this relationship evolves. Is that this is just the last 7,000 years looking at two sites, Marakabi and Spitzkop. And you have it very much an in-phase relationship in the mid-Holocene. But then really on the third Sunday in Lent, apparently, about 5,000 years ago, bam, the relationship changed. And it went from being more or less entirely in phase to the exact opposite and be completely out of phase. This is probably related to these pressure gradients and these changes between the low and high pressure fields between the Benguela and the interior. But it's very interesting when you're thinking about how quickly these systems can adjust to broader changes in global climate. So for the summer rainfall zone, it's not homogeneous. The east and western summer zone are out of phase, and there's clear evidence of precessional forcing, but it's not what we anticipated. In fact, it's the opposite. And that these changes are related to more complex understandings of how these pressure fields work together and what the environmental impact of these changes is over time. So, conclusions. basically, the Earth is a very complicated place. And I've certainly found that the more you know you don't know. All of the paradigms that we started with have been thrown up, and we are in a very exciting place, but it's all breaking new ground. So at least we've made some progress is how I can end this and say thank you for your attention. That's it from me.
Thank you very much, Prof. Questions, colleagues?
Can I ask?
Yes.
It's very interesting presentations, and it is. This is, I think, archaeologically also very important, huh?
Absolutely.
And how this temperature you're using delta C13 and nitrogen 15. What about the oxygen isotopes? That will give you more information, or
there's actually a slide back there. I had deuterium in there. I skipped over it in the interest of time.
Okay.
But yes, we've gotten some oxygen isotopes from the cellulose from some of this material. The delta D, the deuterium from the leaf waxes, is proving a bit simpler to get. But yeah, no, absolutely. It's very interesting to be able to put them all together. So you have, nitrogen as a proxy for aridity. Carbon in some places works that way, but in other places it's more a question of changes in photosynthetic pathways of the plants. So between warm season grasses and cold season grasses, or trees and shrubs.
Yeah.
But indeed, the water isotopes give you insight into the source of the water, the temperature at which it fell, the amount. But the issue we're having is that at this latitude, with this sort of myriad mosaic of circulation systems, that it's very hard to pick out whether we're looking at primarily amount, whether we're looking at primarily temperature, whether we're looking primarily at source.
Okay.
So it's definitely work underway. In some regions, it's very clearly amount, and that's simple. But when you get down south,
but this is your study is not a dry area, but still I think you got the preservations because it's not completely dry like your Kalahandi region.
Well, it's interesting because the driest place, the Spitzkop record, for example, they get about 120 millimeters of rain a year. Okay. But that's just, in a way, a strange metric, because sometimes they'll go for 3 or 4 years without any rain whatsoever. Okay. And the driest place I think we've gotten a good min from is about 50 millimeters of rain a year from near Gobabeb. Okay. So yeah, it varies. It varies from about, I'd say about 50 to 500 mils.
Okay. Very interesting. I'll be in touch with you because we are doing some of the paleo archaeological studies also a little bit.
Yeah, exactly. Do definitely contact me, because we're doing a lot of that in Southern Africa.
Yeah. It's very interesting too.
Now the context is very useful.
Yeah, thank you very much.
Indeed, thank you.
Okay, colleagues, if there's one question, we can allow one more question. Is there any other question?
Do we have time? I have just one observation on this.
Please make your observation, sir.
Yeah, it was very interesting to see the higher rainfall events during the early Holocene period, which we were also observing in Kuwait here, the shift of intertropical convergence zone. Yeah. And then we had higher rainfall events in 8,000 to 6,000 years. And could that shift be another reason why there is a change in the climatological conditions, which you were mentioning about that 5,000 K after that and before that? That is one part. That is one thing. And the second thing is when we compare the top part of the drier and wetter graph, which we're showing at the last part of it, where you have a zigzag change. And then on the top part in the recent years, like at the Meghalayan stage, that is on the recent years, which we also observed that there is again a reversal on that. So I think there is some similarity between different regions. So it would be better when we discuss it on a global scale, like.
Absolutely. I agree entirely, because certainly one of the things that we've found is that basically having records like this give you the means by which you can have meaningful discussions between regions about certainly long-term trends, but also these abrupt climate change events. In Northern Africa, for instance, and the Middle East, there's the African humid period, which is more or less associated with solar insolation, with precessional cycles. And the greening of the Sahara, quote unquote, occurred during a period where they had more summer insolation. And of course, this would be affecting most of the northern tropics in a similar way. And then as that insolation decreased, it crossed a threshold. And in some places, it looks like the transition to drier conditions is extremely abrupt. Indeed, what we're seeing down south is not unrelated to this. We see a change which in some places is very much in phase with records, speleothems from Kunf Cave, from Oman and the Yemen region. My expectation is, since ultimately you're looking in many cases not at local drivers, but more local and regional responses to broader drivers, that there would certainly be, at least in some cases, a common driver that's creating the signal that's observed in, in India and South Africa, or, New Zealand and South Africa, these far field places.
Sure.
Yeah, no, that's what's exciting about the work, is finally we're able to engage in these discussions and make these comparisons. So, yeah.
I have more to discuss with you, but I'll discuss with that with you.
Sure, send me an email. Absolutely.
Okay, folks. I think what you have would be your emails. You can engage with each other. For now, we move to the next speaker, and we are inserting, in this case, a slight change. Professor Ricardo Hirata will be the next speaker, and then we'll follow the plan as it was. Professor Hirata is based at the University of Sao Paulo. He is a geologist, and he's also a former member of the Groundwater Management Advisory Team of the World Bank. He's also, among other places, advised UNESCO, and he's a visiting professor at the University of Costa Rica and Calgary in Canada. May I ask Professor Hirata to make a presentation?
Oh, hi. Good morning, everyone. Again,
Sorry for interruption, Professor Hirata. I'm changing your presentation slides. Please, I'm not sure whether you can be able to see your slides. If you have any, if I'm moving very fast, please, you can tell me stop.
Yes. Okay, I can see my slides.
Oh, thank you.
Yeah, okay, great. Good morning again and again. Sorry for the confusion related to my presentation. I have tried to access the system previously to avoid this problem, but I couldn't solve it, sorry. For me, it's a little bit frustrating when it's because when I can manage this properly. But let's start again and correctly this time, I suppose. Well, for me, it's a big pleasure to be invited for this meeting, and thank you guys for the invitation, and maybe allow me to talk about groundwater and related to climate change and in cities. That's the area that I have worked for many times, and mainly in UNESCO and the World Bank, and also for projects in Latin America. The Latin America actually is the area that is much more I concentrate my effort and my group at the University of Sao Paulo to understand and to how to create some policies to overcome the problems related to climate change in a very poor situation that is in Latin America. Actually, I try to use some examples in Brazil to basically to illustrate the problems of climate change. If you can change the slide for the next one, please. I think one of the biggest problems related to groundwater is its importance is hidden behind official statistics. I like the expression, the behind this official statistics. And I showed examples in the case of the city of São Paulo. It means that the groundwater is under the radar of the perception of the society. Not being in the official statistic bring us many management problems, and also I think that we lose a lot of opportunities. And as I mentioned, one of good example for me is in my hometown, the metropolitan area of São Paulo. The next one, please. São Paulo is the next slide. Vetri, please. The next one. Yeah. Well, São Paulo, yes, this one. São Paulo is a metropolitan area, one of the biggest. It's a mega city with a population of 21 million inhabitants. And the public water supply, the total water supply that is distributed among all the city, that's cover 98% of the city, is the system that's a very complex system of dams, tunnels, and reservoirs, produce 61 cubic meters per second, or distributes at the end of the line 61 cubic meters per second. But 19% of the water comes from surface sources, rivers, dams, small lakes, but mainly rivers. However, São Paulo Metro has more 13,000 private wells, extracting in total more than 11 cubic meters per second. That's a lot of water. But interesting, instead of 1%, because for distribution, 99% is surface, 1% is groundwater. But instead of 1%, that's the official statistic, groundwater accounts for 18% of the total water supply of São Paulo. And during our last drought that affected the whole region of southeast region of the Brazil, the groundwater plays a very, very important role, supplying more than 25%. It means groundwater is not 1% resource, actually, it's almost 20%. São Paulo is dependent on the groundwater, and in some places, in sometimes more than 25%. It's important to mention also that if private wells did not exist, São Paulo's supply would collapse the system. And also it's important to mention that 65% of wells are illegal or no extraction license. It means that the government cannot control the extraction. Actually, even they don't know the existence of the wells. And only a fraction has a regular chemical analysis, including VOCs, and heavy metal is a little bit more common, but VOCs and the new emergent contaminants, that is really rare, endanger the population. And also because of this proportion of just 1%, of course, the government doesn't take care much about the concern about the groundwater. Groundwater is not considered properly in the water resource plans. And if you see the document, it's just solutions based on the surface water, but groundwater actually plays a very, very fundamental importance in the supply of the cities. But the cities not only hide water wells, next one, Well, the last slide show us that the city is just not hide the water wells, but also change completely the hydrogeological cycle in terms of quality, in terms of quantity. I want much more mention about the quantity instead of quality, but São Paulo has a lot of problem of contamination sites, mainly now provoked by chlorinate solvent in brownfields, and mainly because São Paulo is moving from the very industrial places to a more service activity, economic activity. It means that São Paulo is left behind the many places of contamination. But the cities change completely water quality. I want to follow the next slide. The next one, please. Just click. Yeah. This is the graph that I like to show. That's no the previous one. Yeah, this one. This is the study that we conduct. The previous we study that we conduct in the previous one, please. Yes, this one. Yeah.
Okay.
Yeah, that's one. Yeah. This is the case. Urbanization reduced the natural infiltration, but in general, the recharge tend to increase due to the main leakage. That's the case that we study in some places around the world, but particularly in São Paulo, as in other cities like in Bermuda, in Thailand, in Lima, Peru, Mérida, Mexico, Santa Cruz de la Sierra in Bolivia, close to Brazil, and also in São Paulo. In all of the cities, we observe that the natural, this graph shows us better. Here is the precipitation, the rainfall from the very dry area, like in Lima, to a very humid places with more than 100 millimeters per year, and related to the deep infiltration, that means recharge. And this gray area is the natural recharge that we expected from this different climate environment. And these points are the cities, and the dot is the natural recharge without any participation of the cities, and the peak, the arrow is the today recharge because of the city. In all of this case, you have increase in recharge. The most impressive case is in Lima, because Lima is located in a desert with the precipitation that is less than 10 millimeters per year. It's a place that I live 1 year. It's a very wet place, but actually the precipitation is very low, 10, 20 millimeters per year. But because of the city and how the city managed the water, the actual recharge, the real recharge is around 500 millimeters per year. It means that increase a lot. Is, as I mentioned, the same for the other cities. In my case, the city of São Paulo, for 35 or sometimes 200 millimeters jump to 500 millimeters of the recharge. Well, the next slide I invite you guys to move from the southeast Brazil, São Paulo, to the northeast of Brazil. Recife is a very famous place, not just because of the beautiful beaches and the nice carnival that's unfortunately this year is not allowed. We don't have a carnival this year, but the carnival for sure is a very beautiful activity, tourist activity in Recife. But Recife is our fourth largest Brazilian metropolitan region with a population 3.5 million and affected by prolonged drought that caused, because of this, people drilled 13,000 private wells to overcome the problem. And the wells, mostly 90% of the wells are illegal. The next one. Try to understand the problem provoked by this intense groundwater exploitation. People start using the shallowest system that's in the Cenozoic deposits, is unconfined aquifer, but is rapidly this water became saline because of the ocean intrusion caused by this extraction. Because of this, these wells, that's 60, 70 meters depth, tubular wells, were abandoned, and people drill for deeper, and they found another aquifer. That's a Cretaceous system. Next slide, please. Yeah, and that's we call the Cabo system. And because of this intense, very dense exploitation, in some places, this aquifer, the potentiometrical level is below 90 meters below sea level. And but in the whole area that you can see in this map, this red square is the places that you have a much more density of wells. We don't have we haven't had any problem of salinity still, but of course we have the risk for the salinity. The protection of this system is because of a 20-30 meters aquifer that you have above this Cabo system. The Cabo is a very confined system. The next slides, please. Next one. Yeah, the system is a very complex geological system, and that it's possible to see the Cabo here on the base of this system above the Precambrian basement. Okay, and this gray aquitard is the gray aquitard is is protecting the system, and also there is a 4 kilometers from the coast there is a geological structural height that also block the discharge from this aquifer to the ocean. And the recharge of the system, of the Cabo system, is associated with the weathered rock of the basement in the extreme west of the study area. This system is is a small aquifer. It's a very powerful aquifer in terms of the provide water, because we have a lot of wells, and it's important for the city, but it's a very limited system. And you can see the next slide. We conducted many deep studies in geochemistry and also use a different isotope, but I just want to show these results. We have a very old waters, in some places close to the coast, waters with more than 18,000 years before present. We use a carbon-14 to measure, and also to confirm this age of this water, and also the model, flux model, using noble gas. We extracted noble gas and determined the temperature of the recharge that's 8 centigrades below today. It means that in the graph on the right side, it's possible to see the evolution of the temperature according to the age of the water, and that's pretty consistent. It means that the recharge of the water was done a long time ago, and confirmed by isotope and noble gas temperature. That's very interesting. And also it's confirmed our conceptual model about the groundwater flow system in this aquifer. And because of the very low hydraulic gradient, you have a very reduced velocity of groundwater velocity of 0.001 meters per year. As I mentioned, it's a very small aquifer. In total, the aquifer has an extension of 20 kilometers from the recharge to the extreme east below the ocean. This is just 20 kilometers, and with very, very old water. The next one, please. Yeah. This system is a natural protected system, and also is interesting because in the past we had two ocean transgression, one in around 120,000 years ago, and with elevation of 10 meters above the today's sea level. And this elevation of the water provoked the salinization of the carbon system because the level reached the recharge zone. But the second transgression that we experienced 5,000 years ago, it was not allowed to salinize the water, although the whole flat area was covered by the sea level. It means that the aquitard is very powerful to protect this aquifer, but because of the use of the groundwater, and also because of the climate change, we not expect a very promising future. Because of our prediction of the climate change for the scenario of 2100, the sea level expected to rise almost 1 meter, and the reduction of the rainfall in 20%. It means that less rainfall, less recharge. This is the results from some models in prediction for the elevation of the ocean and also the temperature. And we put this, next one, please. We put this information in a mud flow seawater model to predict that what happened in the future, including the marine, and the result show us the problem with the marine intrusion in the carbon system, mainly associated with the exploitation, and the salinization of the both Boa Viagem in Barreiras, that's unconfined aquifer, shallow aquifer, due to the sea level elevation and the recharge reduction. And although this aquifer is less used than the other, many poor people in neighborhoods using this water, extracting water from the dig wells. It means that socially, these wells are also important. Sorry. That's the future that we have for this aquifer, and we predicted that in 2050 the whole carbon system, the Cretaceous confined system, will be salinized. The next one, please. Well, what's next one? What does Recife teach us about tracking clean global climate change. Next one. Well, the global climate change in Recife is reducing the aquifer recharge and groundwater availability and increases salinization in the shallow system. Also, increased population water demand. More temperature, people need more water, and if not associated to awareness programs or saving water technologies, it means that for the population that cannot have access to the public water, it means that they are drilling more wells. The seawater elevation causing loss of unconfined aquifer, increased pressure on the confined system, and increase investment, the necessity of an investment, the climate change increase the necessity of investment in the water sector and how water facilities will operate this new business, consider private users and also investment from the government. The next one. Since the city, of course, another results from the Recife area show us that the city needs to seek more water within themselves. There are many different types of water in the cities, and the Recife has to use this water for different purposes. Next one. Perhaps one of the most way to overcome problems related to climate change involving groundwater is use the conjunctive use of groundwater and surface water together. This is perhaps the most effective way to increase water supply resiliences for cities. Consider the city that you can see in this slide. It's a city supplied almost of time. The next one. The next. Almost of time using the surface water. That's the water. But during the dry season, tubular wells can be used. The next slide. No more surface water. You can extract groundwater, okay, and supply the city during the drought periods. When the rain starts again, you can use again the water from the river, okay, and then supply the city. And also, you can use the next one. You can use the extra water, the water excess, and also treat this water and recharge, recompose the storage of the aquifer to be used in the future. It means that a very integrated system that there are some examples like in Madrid, in the United States, that use this conjunctive use. For the Latin America, the next one, and also in Brazil, we have this type of conjunctive use, but not in a planned way. It's a very spontaneous. It means that the city has private public wells in the cities that extract groundwater, and also the city provide population using surface water. It means that it's a kind of conjunctive use, but it's a very spontaneous. It's not a planned one. A planned one means that you can construct well fields to extract the water, reduce the private wells in the city, and also use, but reduce this pressure in the city, and also use surface water in different time, in different ways. The secret is how to manage the different waters and also reuse water to the benefit of the society and also using as a strategy to reduce the cost of the water. And also sometimes for the field or rural area, you can pay for the environment service of the water for the agriculture activity, not to use it specific water and save water for the city. That means that this is the way to face better the problems related and overcome problems related to climate change. The next one. At the end, that's summarize the most important message from my presentation. Groundwater is more important than the perception of the decision makers and the society. This is, for me, is one of the biggest problems related to groundwater management in the world, not just in the poor and developing countries like in South America and Brazil, but mainly in countries like, in some countries in Europe, in many others in Asia. The perception is really low, and the people don't believe that the groundwater it's really important for the sustainability of our society. We as hydrogeologists mention many numbers, but actually we have to use a better strategy to convince people that the groundwater has to be treated as an equal value as surface water. Not consider the conjunctive use of surface and groundwater cause loss of opportunities and to increase water security in the countries and in the countrysides in the city, which will be aggravated by climate change. And the function of aquifers and the relationship with the rest of the hydrogeological cycle is essential to create efficient management policy. We need to really use the hydrological cycle, not just understand it, but you have to use in a very clever way. And at the end, the groundwater resource should be thought as of a solution and not as a problem, because in many places, in Latin America, people think groundwater as a problem, is a limited resource. They believe that it's a limited resource, and the contamination is a very complicated and that is a hard solution problem. And they say, oh, it's too complicated. And they also prefer to invest a lot of money in surface work. Okay, the next one. Just to say thank you. And if someone is interested to make some questions, please, here.
Yeah, questions.
Thank you.
Welcome. And Ricardo, thank you very much for ending your presentation with those important messages. And that's very important, given that we have politicians who are, and policymakers who are interested in what we do. Questions, colleagues?
Prof, I can see a few more hands rise. I think I notice Satya.
Are they able to speak? Do they have access to can they unmute?
Promote to panel, it's Burukal Mang, I think. I think they can speak.
Okay.
Can I say a comment?
Yes, please.
Go ahead.
Prof.
Dr. Ricardo, thank you very much for your lecture. I absolutely agree for you. I think we need more information about the hydrological and hydrochemical data for the public policies. Congratulations for your conference.
Oh, thank you. Thank you. Yes, it's in Brazil, it's amazing because if you go to the official statistic, you can find the records of the government records, something like 500,000 wells, but actually the whole country has 2.5 million wells, and mainly because 80% of the wells are illegal. Is interesting that if you account how much the money, the investment that was necessary to have 2.5 million wells is 500 million US dollars. In a country that the investment is really low in terms of sanitation and water, the private sector actually is playing a very, very important role to provide water to society with the private investment. And the government actually still don't have the action to try to involve the private sector to increase as a planned strategy to reduce the vulnerability of the city using these private wells. It means that in the city you have the private wells, but actually it's not incorporated in terms of how this water can be used to help the supply of the city. I'm not speaking about to link private wells to the mains, the public network, because it's not allowed because of the quality problem. But the fact that you have a private user using groundwater, it means that they save water for the public water for the others, mainly for the poor people. It means that to have private wells in the cities and providing water help the whole society. It's not the solution. It's not just one solution by one person, but also the solution for the city. And also, I think mainly in Latin America, that's the place that I know pretty well. I think that the government has to change the way to see the private wells. Because in Brazil, many companies or facilities actually see the private wells as a competitors, and they try to close the wells. And actually, I think it's not a good idea. I think that is incorporated these wells as a part of the solution. That's my main message in this sector.
Yes, absolutely agree.
Prof, can I ask one question? The last one. Prof, can I ask one question?
Oh, of course.
Thank you so much, Professor Hirata. Really amazing presentations, excellent. So, but it's another thing. Sorry for the inconvenience in the morning for the technical issues. I would like to ask quick questions. Your presentation is very clear, and also you have mentioned the seawater intrusion possibilities on 2016. It's moved towards the inland area and it's highly affected the aquifer systems. But in that cases, in the metropolitan cities, like saying Sao Paulo, I'm sure it will have the well-structured drainage system and everything. Just I would like to ask you, what are the sources of the pollution in that such a kind of metropolitan cities? Another things, you mentioned the private wells, so many private, but in South Africa also we have the private boreholes the government is allowed. We are maintaining such a policies. So depends on the purpose and depends on the pumping rate, the government is restricted to discharge the pumping rate. So is there any policies in Brazil you are maintain the sustainable aquifer systems? Please.
Oh, yes, yes. The first one, we have a lot of problems in cities, mainly in the in very industrialized cities like São Paulo. You have a lot of places contaminated by chlorinated solvents, actually. there's some statistic that we have, for example, a program try to identify, try to evaluate and remediate aquifers, or risk analysis and evaluate and remediate the aquifers that cover in the metropolitan area almost 3,000 places, okay? Mainly gas stations, but some of a big, there are some big industrial plants too, very complex industrial plants, and a pure phase of chlorinate solvents, etc. But is very timid actually, because we expect to have 10 times more problem than this numbers of official numbers. Again, you have the official numbers, but we believe that you have much more, because we don't have investment enough to find exactly the place in a convenient way. We propose, as university, working together with the government, some methodology to find and localize potential areas based on the vulnerability, based on the classification, contaminant load, etc., etc., etc. But actually, the government has some resistance to adopt this system. There's a political issues associated to that. That's another complication. Regarding the second one, yes, it's a very interesting. We are producing a paper. Actually, recently was published in the Hydrogeology Journal, in the editorial place, together with Stephen Foster from UK and Emilio Custodio from Spain. Both were former IEH presidents. And together we evaluated the problem of illegal wells in the world. Based on that, based on our statistical consideration, actually, to have legal wells actually is much more exception in the world than the rule. There's a much more illegal or unknown wells in the world than legal wells. That's a very problem. If you just leave Central Europe, some countries in extreme Asia like Japan, Korea, and some places, one country in Central America, and also one country, two countries, and also include Mexico, part of Mexico, and Chile. I can say that the rest of the world, Canada, United States, of course, and I can say that the rest of the world has much more illegal than legal wells. That's a global problem. And because of this, people don't understand really the importance. Also, the hydrologists don't understand the important play that groundwater has in the economy and and solve problems, social problems, also for environment. Is totally under the radar. But we have laws. That's the other things. We have laws that control extremely how to drill the wells, how to control the extraction, etc., etc., etc. But people don't follow. It's a law that it doesn't work actually in many countries. In my country, for example, we have the law, and but it doesn't work. And I think that one way is really to participate the users in the process, because normally the law is much more top-down system. It means that you have the law, the state has the capacity to enforce the use of the law, but they don't have people or even the way to apply the law. It means that you have the law, but it's not followed. it means that it still have a lot of problems. If you go to South America, that's the places that I know, you have 80%, 90% of the total wells are illegal or irregular. So that means that it's almost impossible for the government, central government, try to control the correct use of the groundwater. Okay.
Thank you, Prof. Thank you so much.
Okay, thank you for your attention.
Colleagues, I think we are done with this presentation, and thank you very much, Professor Hirata, and also for the patience you have exercised given the glitch this morning. We are now proceeding with the next presentation, and it's by Professor Venkataraman, who is a professor of physics, and his specialization is in atmospheric and space science. He has held a number of positions that are influential in this country, including that of being the Vice President and the President of South African Atmosphere Science Society. Without much ado, may I ask Professor Venkataraman to make a presentation.
Thanks for everyone. It's a real pleasure to meet everyone in online forum, though we thought to have it in the physical way to contact each other and socialize. In fact, I'm also thankful to Vetri. We didn't meet each other, though we are not far away, but I kindly accepted Vetri when he tried to have some talk. But I'm not sure the talk is more relevant to the people who are sitting on this forum. But I could share some of the information on the later slide to indicate what we contributed in terms of water vapor or the rainfall situations using mathematical model simulations later on. That's what I thought to be contributed. In this presentation, what I would like to share is basically I'm from the atmospheric physics and the atmospheric science, and we had a long relationship with the French, with the CNRS, and then we started this program from 2010. And in fact, we're supposed to have that 10 years of celebration of this project, but we couldn't make it due to the pandemic. I could like to share some of the result which has been obtained, but may not be everything, but we can highlight some of the points so that it be interesting for the people to collaborate and also to have some interest on the air pollution and the atmospheric science, which may influence on the hydrology and the water cycle in the atmosphere. Thank you. And again, thanks for the organizers to invite me to give this talk. So as I said, this was the original research project, which we are sharing with myself. I'm the principal investigator from South Africa, and then Professor Hassan Benjeri from Université de la Réunion in France. So that's how it's been operated. And these are the French partners, which you could say that there are French people who are involved. And there also we have South African partners which also been added, and maybe you can see University of Zululand is also partner of that. Dr. Kanyuse Mbata, who's working in the University of Zululand, is participating on this project as well. So what we do in terms of the objectives, so we had a large amount of the objectives to cover. So what we have been given some main aim of the project, where how we've been collaborating each other for last 10 years. So these are the objectives which we thought to be interesting for both the countries. The atmospheric pollution and climate change in Southern Africa. It is not only South Africa, but we include some of the neighboring countries, including that. Then we study on the tropospheric ozone and aerosol studies over Indian Ocean region, the greenhouse gas measurements and the middle atmospheric dynamics and thermal structures, and some of the comparative studies to see how the satellite observation and the ground-based observations in terms of the quality, and then to see the water vapor cycle that could be important for the current conference which is going on. and the ozone variability and UV radiation in the southern tropics. As I said, I'm not only one person involved on this, and we have a number of researchers in South Africa, a number of people from France has been involved. As a principal investigator of the project, I could like to give some few. So why we do this study, if you look at it, that before I switch on this video, but maybe I can't mute the sound because I need to speak as well in the same story. So what you see on the top left is the smoke over the world, and it's for about 100 years. How does it been changing? So if you see on the top, there's a smoke or the dust which has been moving for over the European region, but it has been spread over into the globe in the later scale. So we noticed that from 1970 or around 1975, there's a region, even in Africa, there is a lot of dust which has been transported and which is moving across the things. On your top right, you see that that's important that to see regarding the conference, we have a lot of drought in some places, including South Africa. Hope you people know that we had a zero water level in Cape Town. That was not a long time ago, but it's about like 5 years, less than 5 years ago. On the other hand, we have in Durban, so you are in KZN, and then we have a lot of floods. Basically, the rainfall is too high in that. So that's what you see on the bottom right-hand side. On the bottom left, we have a two graph which gives animation. The one which shows that the ozone variations over the globe, and then the other side it shows the CO variation in the globe. As I said, I don't want to run this video for long, but you can see the cyclic movement of the things and how does it change over a year. Unfortunately, this is not my animations. This I just picked up from the site, and I thought it would be interesting for the people to look. So you can see all the changes over the years and how does it influence. So the drought place which you see here is our localized in South Africa. And the rain one, which I don't want to switch it on, as I said, we have the sound under the rain which has been occurred very recently, about 3 years ago, and then devastated some of the areas as well. On this area, you can see now that the smoke which is coming out in South Africa, that is the power plants where it has been produced, most of the emissions coming out from there. Okay, so with that slide, which one gives a more importance why we need to study the atmospheric science, and it has been interrelated to many of the field and many of the discipline as well. Since you have seen that number of objectives on the project, but we have combined them into 3 actions. The action 1, which respect that impact of anthropogenic pollution in Southern Africa on climate change and health. The action 2, which will be on the aerosol radiative effects over the western coast of Southern Africa. The action 3, which is stratospheric and tropospheric interactions, which include ozone, water vapor, aerosols, and UV radiation variability, and its respective changes over the years. Respectively, all the actions has been shared between one team investigator from South Africa and the other team investigator from France. So if you look at it, the first action which we have, so what you see here again, the emission levels which has been recorded, that's a block carbon emissions in South Africa from 1990 to 2014, where you can see the different components on the different contributions of this block carbon emissions in the country, including industries, the power plants, the domestic fires, and the flooding emissions and everything. So also that if you look at it in terms of the sites, most of the sites which we have observed, or we call it as a hotspot region in South Africa, and some of the sites are mentioned here, and you can see that the contributions from each of the sites, and you can also see how we able to model it in terms of the regional climate model, and then looking at the observations, how does it match? So more or less, we could able to have identify more than 60% relationship, or to be able to monitor the capacity of the block carbon concentrations in the localized place, apart from the observations. If you look at the wet and dry deposition at South Africa, so there are different chemicals over in the soil or in the land which you can help you able to monitor it. So that's what you see on top right hand side, on the right hand side of the slide. So if you look at it, that aerosol and the pollutions, we also look at it in the localized, very localized place. That means here what happened that we given the census to the household people. In the house settlement in South Africa, you have a different kind of a people. You know that it's also due to their economic level, and some people are in urban, some people are in local, and they're also the cooking conditions in their house is different from one to another. So what happened here is we're given a localized sensor in their house, and then to monitor what is the black carbon emission level in different kind of the house. And then to study that what is to give more public awareness how to control the emissions which has been caused by the public in that region kind of. So we can see on these graphs with respect to the different samples which have been established. Again, depends on that what we want to achieve is to give awareness for the public and try to correct some of the factors which can be reduced. So if you look at it the other way, the aerosol radiative effects, which is also most important in Southern Africa. But here we also try to monitor the situations whether that the radiation effect which could bring either warming or a cooling effect in the country. You can see on the top left-hand side where we have the temperatures in increasing levels, which you can see is increasing, but we do not have that level of 2 degrees or 3 degrees Celsius at this moment, but we are approaching to that. So that's the surface temperature over the last few decades. And if you look at on the other side, whether we want to predict this, the aerosols, whether it could bring a radiative cooling or radiative warming, but the model doesn't predict very well. Most of the models, sometimes we could able to see the cooling effect, and then some other time you would see that warming effect. So that means whatever the input which we given to the model, which need to be revisited, and then to look at it, how does it change, and then to adapt that system, it brings some more complicated situations. But the study, what we were trying to do is to see this aerosol, the source of aerosol and contribution of the aerosol and the transport of aerosol from one region to another region. And that's we can able to address it on this action. We can also see that the biomass burning aerosols, you can even approach in the cloud. And then most of the time it may be appear as a brown, and the people could call it as a brown cloud, and then we can able to study this kind of information. But again, we are not restricted to that our observations only with the ground-based. So we also use a number of satellite measurements, and then the objective is also to see how we can refill when there is no ground-based observations, where you can complement with the satellite observations as well. And another way to also validate the measurements in both the ways, in ground-based and the space-borne instrument. One of the program very recently we took over, that was in about 2 years ago, which is a combination between NASA and South Africa on the Airflow project, where that NASA has agreed to launch a few local flights, and which inbound with the number of air pollution measurements. And then we had measurements in the ground-based, and this project has been made over Namibia. To see, because Namibia is not far from South Africa, but it's a border region where you can have some influence of aerosol transport from the region to South Africa, including the Sahara dust, which will be transported over that region kind of it. We could able to see some of the phenomena which has happened, and then we could also observe that the warming effect during that the simulation which the observation we made, and then the simulation has been followed on that. Also, this project has been have more success on this action itself. So we had a number of other funding which also been contributed into this. In terms of the stratospheric tropospheric interactions, so we've been working on different objectives of that. As I said, in the middle atmospheric dynamics, ozone and temperatures, and some of the ground-based UV radiation and the ozone for the human health and Indian Ocean. Again, I give only a few slides. Later on, maybe I concentrate on some slides related to hydrology in terms of the rainfall. So if you look at it here, this is observations in terms of ozone, and we adopt like a linear regression model, which we call as a trend run model, and where you could be able to see the intensity of the ozone values per decade, how does it been changing over the latitude. So these are the number of stations, which we call it the SADOS, which is South African or Southern Africa, Southern Hemisphere Additional Ozone Sonde, which has been administered by, again, NASA. And one of the sites in South Africa is Irene, where we launched this ozone sonde. But due to the funding limitations, we used to launch only at least once in a month, or if possible, we launched 2 times in a month the ozone balloon to be launched, and then we could able to measure the height profile of ozone, and then can be able to use it for the monitoring purpose. But what you could be able to see here again, that by the latitude, by the longitude, it varies, the ozone variations in the globe or in the Southern Hemisphere especially. We also studied some of the phenomena which also be interesting for our colleagues, which I have a talk from Sao Paulo and other colleagues. Recently, we also have published one of the great fire which has took over in Brazil. I'm not sure, it was in 2019, if I recall that. And then that has been impacted, and how does it been transported, which has been studied in more in details as well with our partners, with the French colleagues, and also from Brazil. So this emission, which is a Calpico volcanic eruptions, which has been happened in Chile for about 2015, but we could able to see the effect of this pollution, the volcanic eruptions in South Africa, and that has been transported. So you see on your top on the right hand side, where the plume has been transported over to South African region. But it took some time, but rather than that, there could be a large amount of a transport in the atmosphere, which can also influence the atmospheric effect in the country. And then if you look at it here, is the biomass burning, which happens in the country due to the agricultural reason. This has been predicted using Moody's with the fire index. So what you could see clearly that April and September, those are the 2 dominant months, the one which says no burning, and then the other one which brings out to see there is a high burning in the period of September. So where you could be able to see even the carbon monoxide emissions during that time period. So where you can see April, which is look like a more quiet conditions, where you have more carbon monoxide emissions, whereas in September, where you can able to identify the large amount of carbon monoxide emissions in the region, especially in September during biomass period. Apart from that, we also used some of our satellite products, which has been localized and studied. Here is Kneshna, that's in Cape Town region, where that the biomass burning has devastated large amount of hectares of lands. And we could be able to see that the graph, which is shown here on the bottom on your right hand side, B and C, the B which shows before the fire, and then after the fire, you can see how much the land has been devastated. And there is need to be have a control on that as well to see whether we can control on these fires as well. And this has been studied using different satellite products, and then we could be able to identify how we can use the satellite products in the country to study such kind of events, even it's a localized one. Apart from that, we also focused on the UV radiations. So here, one of my colleagues has been concentrated to see how much this UV radiation happened in the narrow region versus in the wider region. So here, what you see that 2 kind of the pathways, between the building, and the distance between these 2 building and the path the people could walk on that. So it's very narrow, but the other side where you have very wider region. So that means the sun radiation which comes into the wider region, whereas in the narrow region, which is most important to see how does impact on the human people when they are walking around there. So that has been also undertaken by my colleagues. And then we also did some of the work in terms of the UV radiations, which using different sensors. And we exposed to see how much does it happen there. Apart from that, our South African Weather Service, and we also called a network called South African University Solar Radiation Network. So that means it's a 2 network which is operating on this UV radiations. I come to the next slide, why we need such different networks to study in the country. The reason here, what you see is we did calibrations to make sure that the quality of the data, what we bring out, it will be in good in terms of that, and that the maintenance has been happening like almost in a yearly basis to maintain the instrument and to give you a good quality data. As I said in the earlier, the reason why we have been trying to do is to see this arithmetic weighted irradiance in terms of the UV, and then bring the public to be aware of the situation, to see how much the UV radiation is harmful and how much is not required. You don't require any protections to be followed. As in South Africa, because you know that we have a number of coastal regions, including Durban, Cape Town, and Port Elizabeth, the people need to be aware of the UV everyday basis. So that was another reason for South African Weather Service, where we're trying to forecast the UV index almost in the daily basis as well. So this is one of the study which has been taken for one of the region, and then where you can see sometime where we have some extreme risk of UV radiations coming to the country there. Apart from that, we, on this collaboration between South Africa and France, we normally organize some of the training workshop, and we've been successful until 5 times until to the 2019. We may have one again during this year if the pandemic ends. And mainly we're trying to get some students to get focused and then to trained on this atmospheric remote sensing, and also to more focused on the atmospheric science. As I said, this may not be more interesting for you, but it maybe have some connections. As I said, there is no way at this moment the climate change, the atmospheric science need to be interlinked one to another. So this study, which I thought to be useful, I thought I didn't say to Vetri as well before I shared this one. I thought it could be useful. The reason, they have 2 reasons. The one is this study has been done in University of Zululand, and it was done by a PhD student who registered in mathematical science. And the other reason that it could relate to the conference as well, where we did this, the study has been done using the rainfall over 14 stations in South African Weather Service, which has been monitored. And the data has been used from 1980 to 2018. And the idea behind is to see the repetition of the rainfall when we were trying to get this mode decomposition, using empirical mode decomposition on the mathematical model, and to see that whether we could be able to repeat similar kind of a rainfall in some other years, and using a different atmospheric forces which we expect. So what you see here, these are the number of stations. As I said, there are 14 stations which we have used, and where you could be able to see the rainfall, the maximum or the highest rainfall, even reaching into 288 millimeter in a particular day or particular time over the in the Cape Town regions. But on the other side, we found we had a what we call the zero level water on the other side. So that was an interesting fact which we interested on that thesis. So here you see that the rainfall variability over the different Western Cape regions, which we given again May, June, July, August, which is the December or the winter periods in the country, where you can be able to see again with respect to the months, where you could be able to pick up in August, the variabilities become higher compared to the other months. Again, the winter months is more or less, we may not have expect more rainfall in that region there, except we have a summer and the other period where we expect more rainfalls. What we did that we used that multiple linear regressions on this model, and then we tried again to see whether we can relate this into the vegetation, which will be important for the agricultural and the farming people. And this model again is ensemble mode decomposition using wavelet analysis on the mathematical concept, and then to see what are the main contributing factors there. Again, we didn't use number of variables in the atmospheric, but it could be interesting to add more variables and see how does it vary. But here we took the precipitation, temperature, and vapor pressure, and cloud cover and soil marshes to identify. And his PhD study has been focused mainly on 2 regions. The one we concentrated as in the vineyards. So hope you know that our people might be like Cape Town wine. So that's a place where you get that. To see how much the vineyard has been affected. in terms of these variabilities. So what we have on the other side, we found on the KZN side, where is the most dominant crops is the sugarcane. So that's what we try to identify. How does it been varied with respect to this rainfall and this variability, but again, concentrated only on few. What we found that if you look at that, the observed and predicted based on this ensemble mode decompositions, it could match, it could have a very good relation if we add more variables into that as well. But more or less, we found 80% observed versus the predicted one using NDVI. So what's see on this vegetation index? So that means the vegetation index is very high. That means is more or less it's good for the agricultural. And the vegetation index is very low. That means where you identify it's a drought region, which is happening, or the green or the agricultural product is less in that region. So what we found between these two regions in Western Cape and the KZN, the grape vine, which if you look at it, that what we found is the rainfall is the more impact than the temperatures, that the surface temperatures. Whereas on the sugarcane, where we identified the variability of temperatures has an impact rather than the rainfall, which also important when the sugarcane is in the growing stage. Otherwise, we found that the seasonal and the predictability is like it's been repeating for about 26 months, which is, we call it in the atmospheric science is quasi-biennial oscillations. That's what I thought to give that, because we didn't do much work on the rainfall and the stuff, but it could be interesting to look at it again. So I would like to thank my colleagues on the funding agency on this project. So there are a number of people who have been contributed on that. With that, I would like to end my presentation and then invite some questions. Thank you.
Colleagues, you're free to ask the questions. Thank you very much, Prof.
Professor Siepe, there's a hand that's raised.
And do they have access to the mic? And if they do, they can shoot.
Okay, I've given them
Yes.
access.
Yes, I gave accepted. Yeah.
Okay.
Hi, Prof. Can you hear?
Yes, we can hear you.
Yes, we could hear you.
Oh, thank you very much, Prof. Siva, for such a great presentation. But just out of my curiosity, I just want to know. I see that for the grape wine you use NDVI, and for sugarcane you mention or you pretend that the temperature is more important. Okay. So don't you think that maybe sugarcane, because it's grown in KZN, there's also some irrigation in other areas, why other sides like the south coast and so forth, it's mostly rain-fed. Don't you think that maybe there might be an influence or importance of both the precipitation and temperature in that case? And why don't you think maybe, or do you think it would be advisable to use maybe in indices such as maybe the drought indices that maybe incorporate the influence of both the temperature and precipitation? Just out of my curiosity.
Thank you for the question. Yeah, but it's a it's a very good question anyhow. But as I said in the beginning, it was an exploring study. We tried to see whether we contribute anything on this direction using the ensemble mode decomposition and the empirical mode decomposition of the long-term data series what we got from South African Weather Service. Otherwise, yes, it's most. We get localized into
it was an update. You just needed to random updates.
It could be interesting to have a localized, and also, as you said, that yes, we can also use some dry index as well to see and the region which is dry and also the vegetation. So it could be useful, but as I said, we have concentrated here on this study where we have a long-term data series where which you can able to predict and then use a decomposition model to decompose the larger frequency of it.
Okay, no, thank you very much, Prof.
With that, maybe if I allow Vetri, that I would like to bring, if there is any PhD students who will be interested on the atmospheric science, there is an opportunity for the postdoc. If you are available, if you're interested, you may be able to apply for it. So the postdoc is from my other leg in the astrophysics and space science, where we're trying to relate the atmospheric interaction with the space science and astrophysics. And it's if you are completed your PhDs and if you are interested to any postdoc opportunities, you are most welcome to contact me. And this current application is ending by next week, by 10th of February. So you're most welcome to apply for it if you are interested. Thank you.
Thank you so much, Professor Jan. Thanks for your invitation. Definitely, I will keep in touch with you. I will discuss with my colleague and my students. Those who are interested, I will ask them to apply for this postdoc position. Then further collaboration, definitely I will keep in touch. We can try to do some new collaboration near future. Thank you so much, Prof.
Okay, I also want to thank Prof for the offer from the university, and I'm sure students will be very interested. With that, colleagues, this ends my engagement with you, and from now on, my co-chair, Brian, will take over. Thank you very much for a wonderful session.
Thank you. All right, so moving quickly along, it's my great pleasure to introduce Professor Deemri from Jawaharlal Nehru University in India. He is an expert in the Indian winter monsoon, and that is what I believe we're going to be hearing at least in part from him about today, but under the broader topic of climate change.
Thank you, Professor Brian. It's my pleasure to be here. And thank you, Professor Elumai, for giving this opportunity to share I'm sharing my screen. I hope everybody is able to see this.
Yep, looks good.
Okay. So I chose, after my deliberations and few email exchanges, I chose to talk on climate over Himalaya. Himalaya per se is a very regional massive which is protruding out of the Earth's surface. However, it impacts very many weather systems at local level, regional level, and even at the global scale also. Importantly, what I want to highlight that with the origin of Himalayas, there are geologists here, they know it better than me. With the origin of Himalaya from 50 million years back, I was listening various talk on paleoclimate and various modeling strategies. The Indian summer monsoon as well as Indian winter monsoon has come in, and hence the regional weather and climate has a very drastic change from one scale to another scale in due course of time. And in this regional and local scale, very many people have provided various kinds of research looking from various lenses. Some of them has looked into the heterogeneous topography. This is a beautiful and complex massif which attracts not only the adventurers, vagabonds, but various researchers from across the globe and mountaineers. And it is dictated as so far as a water storage by virtue of its positioning in such and receiving precipitation in various form during summertime. Indian summer monsoon comes from down south and yields precipitation at lower level and tries to climb up, and hence you have a orographic forcings comes into the picture. In winter monsoon time, you have a westerlies coming from Mediterranean Sea over it, and they are dropping precipitation from top, and hence you have glaciers, snow cover, and so on and so forth. Various people have also talked about that, how it's a unique and complex shape of Himalaya, and its vulnerability to the natural and man-made processes are so important that we need to understand this water tower, because very many habitats across the Himalaya is dependent on this, habitat is dependent on this. Simultaneously, in the context of recent global warming or climate change, there is a very important winter warming has been seen increasing much, rate is higher than the summer warming. And not only that, there is environmental dependent warming is taking place. It means that elevation versus the warming has not a homogeneous rate. They are forming in a different magnitude, different sign and significance of change. So there are very complex interactions of various physical processes are happening. That's what I'm limiting here in the present discussion today. And I'll be talking on the future of the climate change to provide what's happening over the Himalayan region. So if you look at the Himalaya per se, what I have seen it has a very unique topographical heterogeneity and land use variability all across it, right from south cross section. If you climb up, it is climbing from 500 meters roughly to 6,000 to 7,000 meters. And this rise is not uniform. There is a cascading undulation of ridges, valley, and as I know, working with Himalaya, there are 4 or 5 ranges are running across in the western part of it. That is the Jaskar, Karakoram, Jaskar, Ladakh, Great Himalaya, and Pir Panjal. So by virtue of this cascading range, the interaction of the above atmosphere within this surface becomes too complex to understand the physical processes, and this leads to the climate understanding with uncertainty, because we also do not have very many observations over this region. So paucity of observation, topographic complexities, land use heterogeneity makes this region so interesting to study from geological point of view. My preceding professor was talking atmospheric point of view. There is a paleoclimate, river hydrology, and there are so many complex socioeconomic problems, gender, and so on and so forth. So I'm picking with a very basic fundamental of the climatic uncertainties first, to understand that how good we know the Himalaya with the available observation. I picked up the blue above right left hand blue graph. If you see, there are the 3 precipitation averages from last 30 years over June, July, August, September. If you look very carefully over these Aphrodite, GPCC, and CRU, all these 3 graded observations, they reflect a very different kind of spatial distribution. Within the observations, we see that there are a difference among them, except the larger signature of increase of precipitation in the northern eastern Himalayan region. What I mean to say here by highlighting the regarded observation in itself, that the preparation of the synthetic regarded observation itself has a varying uncertainty among themselves, apart from the models which I'll be discussing in later scale. And if you come to the altitudinal uncertainty below blue color graph, we find that the lower elevation, if you look at that, at lower elevation, your spread of precipitation in millimeter per day is much higher. But as you keep climbing up, it gets clustered over the higher elevations. This is elevations are running from 0 to 7,000 meters above the Himalayan region, and I have selected the corresponding grids within the study region. And peculiar thing what we notice here, that of course at the lower foothill Himalayas we have a orographic forcing interactions, which is leading the precipitation to have a low precipitation intensity to be spreading in a larger values. As we climb up to the higher mountain, we have a clustering very close to each other because of this very limited amount of moisture is rising up to that level. However, when you are looking at the mid elevation range, we have very not very defined distribution of the precipitation intensity, and hence there is a kind of uncertainty. Looking at the precipitation trend, if you look at that of last 30-40 years, we find that precipitation trend millimeter per day per year is decreased in the foothill of Himalayas, but as we slowly climb up, it increases in 30 years, and as we cross the mid Himalaya and we go to the higher Himalayas, the trend is in positive. It means that trend is decreasing in below the mid Himalaya and trend is increasing above the mid Himalaya. I will come and discuss this mid Himalayan threshold, where characteristic below it is entirely different and characteristic above it is entirely different. I'll get back to that point later in my few slides with more factuals, which will let us know that mid Himalaya acts as a kind of threshold over this region of the Indian Himalayan region. Similarly, this temperature, 2 meter temperature at degree centigrade, also in different seasons. First column is for winter, second column is for spring, March, April, May. third column is June, July, August, September, fourth column is October, November. And again, I picked up whatever the available temperature records, gridded records I have, and I try to compare first among themselves that how way away they are from each other within the observations available from various statistical crunching, statistical method, stretching, or whatever. I am not going how these statistical method have prepared these gridded data. There are different methods. Some are robust, some are less robust. Of course, intercomparison has been made. And of course, then as we climb up over the Himalaya, temperature decreases. As we all know that there is a lapse rate concept comes here. But let me tell you, we have also worked over the atmospheric lapse rate. In Himalayan region, atmospheric lapse rate doesn't work. Vertical atmosphere temperature lapse rate doesn't work because the valley walls interact with the vertical atmosphere, and since we have a valley walls here, the atmospheric temperature lapse rate doesn't work as it acts in the flat topography or flat terrain, because there is an interaction from the valley walls. Hence we have defined the slope environment lapse rate over the Indian Himalayan region in particular based on the observation. Codex experiment has been done with certain objectives, and I was involved in this up to certain extent, and then hence all of here know the modeling strategy here. So most of you are aware. So I'm just using that modeling strategy and trying to prove my points, whatever is available with me. And based on that, I'm trying to say what all, I'm not going in detail called Codex experiment. I assume that all of us are now very well aware of that. Now we have moved to the Codex core, which is at much finer resolution. Hopefully soon I'll share the results. If you look at these model uncertainty and bias in precipitation in particular, we look at the spatial distribution green and brown color graph here. We saw that here the lower Himalaya is drier as compared to the observation, corresponding observation. But as we go at the higher Himalayas, this is the wet bias is happening. It means that the moisture interaction, when orography interacts within the model environment, we find that there is a kind of lagging of the precipitation forming mechanism in the model. So model particularly does not truly represent the precipitation forming mechanism as far as the foothill of Himalayas, where the orographic initiation interaction occurs very first hand by the flow, general flow along the foothill of Himalaya. But however, as it climbs up in the Himalaya, we see that and the higher Himalaya just reverse happens. The model is more wet as comparison to the corresponding observation. I am again not repeating that observation itself has certain uncertainty as I have shown in the first slide. However, if you look this line graph on the left hand corner, we find that most of the model has a peak occur leading to the Indian summer monsoon rainfall. However, there is a lead and lag corresponding to the observation. And here I am using the Aphrodite observation. And particularly when I use the spatial average ensemble of these 11 members, I find that in most of the cases, higher Himalaya still remains wet, whereas the lower Himalaya is showing the dry kind of distribution. And when I am comparing the altitudinal distribution in blue dots, if you look at the scatter right hand below corner, we find that in case of higher Himalayas, most of the model are showing the clustering of this Himalaya here, as because it's much closer to the bias is the wet bias. But however, having said that, there is a very close clustering of the scatters is seen in the higher Himalaya. In the lower Himalaya, it's of course dry bias and the spread has been captured. So this is very peculiar kind of distribution which we in general do not see in lower and mid Himalayas. That's what is my emphasis with this figure, that however, the model could able to replicate the natural environment for higher Himalayas where precipitation intensities within 0 to 10 millimeter per day is very well replicated in higher Himalayas. Further uncertainty, if you look at in the model, we corresponding to these observations, we of course did a lot of experiment on these model plots, and we find that lower elevation and lower intensity precipitation in observation and model are very well captured in this environment. But as we go for higher events, suppose a cloud burst or heavy extreme rains, they are not coming very well represented in the model. However, their distribution, frequency distribution in the lower range is well captured. But as we go further in the higher ranges of precipitation, this is very deviating away, and hence we try to look at what is the spatial mean of the model and what is the extreme plus minus standard deviation and all those things. So interim conclusion based on only precipitation, what we found from our study is that individual model performances vary in capturing various aspects. And we must note it here that Himalayan orographic representation within the model topography needs to be very looked carefully because of land use, land cover, and because there is a sensible and latent heat flux. Various fluxes exchange take place in the coupled manner from the Himalayan surface to the free atmosphere, and also the considerable uncertainty also exists in most of the model. However, we in the separate studies we have done the bias correction based on this model, and we found that there is a possibility of by using the bias correction and improve upon the model data, model output for hydrological or glaciological purpose. Coming to the model uncertainty in temperature, again we find that lower elevations are not much colder, but as we climb up in the higher Himalayas, if you look at the blue color, the model is much colder as compared to the lower elevation of the Himalaya. This could also lead one of the conclusion when we see the moisture temperature feedback in particular over the Himalayan region. The lower temperature in the higher region may initiate the precipitation to occur much faster, and that could be one of the reasons that the higher Himalaya is having more amount of precipitation. Higher Himalaya within the model physics is showing more wet, whereas in the lower Himalaya we do not have much more temperature moisture feedback to the formation of precipitation forming mechanism. So that could be one finding we can say with precipitation, and in particular when we have taken a distribution of available precipitation, available temperature data from the various model combinations, we could see that, of course, the temperature is the cold bias if you look at this line graph. But however, we find that the march of the temperature in the monthly mean temperature march is very similar. This increases by the May and then again decreases by September, though this is a cold bias than the corresponding observation. Their mean is shifted in some of the case when we have a probability distribution function with corresponding observation from Afrotemp. We find somewhere their mean of temperature is shifted in the Gaussian distribution and they show the cold bias. However, more importantly, in some of the cases, we find that the spread of these temperature in different season is also particularly different. Interestingly, in the month of June, July, August, September, your environment is mostly moist by virtue of this moisture temperature dampening or moisture dampening, and or vice versa, both occurs over this region. And hence, as we climb up in the higher Himalayas in model physics, we find that there is an altitudinal distribution of model which shows that intensification of colder bias with the elevation occurs. As we climb up more and more in the model data, we find it is having the colder bias. Now, with this uncertainty over this Himalayan region, I am coming to the climate change debate of the Himalaya, because it has a huge implication, manifestation on the society, water, snow, river hydrology, and so forth. And in near future, we find, I think somebody has referred of the Indian summer monsoon before my talk. And in this case, what we are finding in particular over the eastern Himalayan region, monsoon precipitation is deficiting. This is near future change 2020 to 2049. And based on these 30 years data, we found that there is a kind of lesser amount of precipitation probably will occur in the eastern side of Himalaya, whereas western side of Himalaya is likely to have more amount of precipitation in the near future. And in another study, separate study, we have seen that there is a kind of shifting of Indian summer monsoon towards west of India. If you have Indian map in your mind, we have found that Indian monsoon march is slightly shifting toward westward, and that is the reason that you have a lot of flooding events occurring in the Rajasthan, Gujarat, and so on and so forth, whereas in the eastern side the monsoon is not driving that in. However, when we have a 21st century projection of 8 member, we do not have much distinct change or increase or decrease over this, because it may be because when we are talking of ensemble, that some of the increase and decrease precipitation is cancelling each other. However, there is a lot of uncertainty in precipitation if you look at the shaded graph. Elevation dependent change in precipitation from present shows very interesting finding with different RCPs, and we found that in the lower elevation your variability is going to be increased higher and higher over the Indian Himalayan region. But as we climb up in the higher elevations like 5,000 meter or 6,000 meter, we find that the elevation variability is not much over this region. Of course, one of the reason is that your moisture is not climbing up that much in these formulation because of the orographic forcing. Hence, most of the precipitation forming mechanism or precipitation yielding mechanism is limited to the lower to mid Himalayan region, where you have more amount of variability is going on. Now, the future projection of seasonal mean of temperature, if you look at that, of course, all the 4 seasons shows that there is an increase of increase of temperature happening over all of the Himalayan region with certain uncertainty over this region. We try to be as accurate as possible, and we find that higher rate of warming at higher elevation region is more prominent during winter and post-monsoon season, and also higher spatial as well as intermodal difference with increase at elevation is seen, and the highest difference is seen between 4,000 to 6,000 meters. This vertical distribution of graph, if you look at that at this winter and post-monsoon, that is October, November, we find that the consistent increasing trend in all the season has been seen in RCP 8.5. However, there is a pronounced winter warming and post-monsoon warming has been seen. We have yet to see what is the response of that warming. I do understand that at the time of monsoon, there will be dampening of the temperature by virtue of the available moisture. However, why not in spring? So we are yet to see this kind of analysis over this region and to look into that. And particularly in case of winter warming elevation and mechanism in the model, we try to look at the available model here, available data here to define the winter warming elevation dependency using the downward long wave radiation, mean temperature, cloud fraction, soil. So whatever is the possible available variable we have, snow melt. And in this figure in particular, I want to emphasize that there is a kind of threshold which is roughly at 3,000 meters, which shows that higher elevation shows the amplified warming rate during winter, and the pattern is very clearly reflected if you look at the figure B, which is in the pink color, yellow color, which is the downwelling long wave radiation. So in these two regions and surface albedo and the cloud fraction, in these 3 findings shows that somewhere there is roughly at 3,000 meters, your kind of a mechanism happens in the Indian Himalayan region, that below 3,000 meter your characteristic is different, and beyond above 3,000 meter your characteristic of the warming elevation dependent warming changes. So we try to explain this with another hypothesis also. We have tried to give that when the trend of temperature of skin, if you look at the kind of for the Western Himalayan region in particular, the Karakoram anomaly is debated. We find that temperature is cooling down by virtue of the decreased temperature. We have a increased surface snow amount because surface snow is not melting in that context. And by virtue of this, the trend of surface upwelling shortwave radiation also is increasing. So you are not retaining much energy within the snow mass. Hence, the total mass over snow in the Karakoram is likely to be retaining for longer time. Hence, that is the reason of Karakoram behaving as anomalous. So this is a kind of hypothesis we try to provide based on the model. Of course, there can be debate by virtue of the paucity or severity of data. Yes, I agree with that. However, this model-based hypothesis can act as a benchmark over this region, and that's what we try to explain over the Karakoram comparison between the Karakoram and Ladakh. And here distinctly we have found that when we climb elevation dependent of precipitation and temperature in this overview graph, we find that there is a more difference at the higher elevation in the blue color. If you look the graph which is for Karakoram and the red color for the Ladakh adjacent region of the Karakoram, we find over the Karakoram, this is one of the very typical reasons that most of the elevation ranges in the cold red region receive higher precipitation than Karakoram, except over the lower elevation ranges. So these are the fundamentally we have seen based on the Afrotemp and regulated data which is available in this region. So in case of cold arid region, decreasing vertical elevation dependent changes in precipitation is also seen, which is not the case of over the Karakoram region. And when we find based on the aridity, we find the decadal trend of aridity index in particular shows most interesting rationale for affirmation of Karakoram anomaly, in which we saw the categorically increasing trend of aridity index, which is increasing in last 35 years over the Karakoram, which is not the case in the adjacent Ladakh region. And this shows that in this decade, Karakoram is kind of having increased in aridity index, which thus in the process is kind of converging or corroborating the fact that higher moisture is transformed into the mass gain over the Karakoram region, which is not the case over this. Apart from that, we also looked at the lifting condensation level pattern over this region based on the available data from this regulated analysis. And we found that lifting condensation level determines how that moisture is getting dumped over the Karakoram region. And we saw that trends of lifting condensation level over this summertime shows that lowering over the Karakoram within the cold arid region. Hence, what we want to say here, what we want to mention here, that by virtue of lifting condensation level lowering over the Karakoram region, in itself, whatever the moisture is coming, it is getting saturated or it is getting dumped over the Karakoram region. So that is the few physical atmospheric processes, limitations we are processing. I again want to repeat that I'm not glaciologist and no glacier and mass balance process is discussed in this kind of understanding.
Excuse me, Professor Dimri, if you could find a good place to wrap up, that'd be fantastic because we're running a bit over time.
Oh, it was not 30 minutes for me? Okay. So I'll do that. Yes, I'll do that.
Thank you very much.
Similarly, we saw that over the increasing trend of precipitation over the upper Indus Basin, over snow-fed higher elevation and lower elevation over the basin is showing decline precipitation trend. So maybe this section I have this particular following section which I was thinking of discussing primarily is based on the subsection of the Indian Himalayas like Brahmaputra, Ganges, and Indus Basin. However, with the paucity time, I will try to close it here with the final comment that we have to kind of be very subtle as far as we are talking of this observation on the Indian Himalaya region, where there is a lot of uncertainty in terms of variability, magnitude, and atmospheric processes are yet to be established based on various modeling needs, which are truly represented over the Himalayan region, which has itself as a limitation of the data. So with this, I thank you for giving me this opportunity, Chair, Professor West, and I'll be ready for any question if somebody has.
Thank you so much, Professor Dimri. That was very interesting.
Thank you.
I'm afraid we might not have time for any questions right now, but I would definitely invite anyone to contact Professor Dimri directly via email. We'll move on quickly and without further ado to Dr. Mbata from the University of Zululand, who's an atmospheric physicist, and will be telling us about forecasting geophysical data time series using deep learning, which sounds rather intense. Dr. Mbata.
Okay, thank you. I hope you can see my screen. You can see my share.
Yep, looks good.
Yep, okay. Let me, okay. Well, I thought of this topic because I was really not sure about this topic actually, because which time series would you use? For instance, which data would you use? However, I thought, let me choose 3 different types of time series and show how one can forecast those time series. This is important for geophysical data because of different problems with gaps, and also just focusing the time series, really just wanting to know what could happen next before, or so that you can take proper action. So what I did is just a quick highlight for you. You may know that usually when you have time series like this one here, you may have gaps and you may think about different ways how you can close those gaps. Really, I'm talking about time series forecasting and gaps, but you know, it is just to convince you people that you can really use these methods are much more accurate than what you may know. Otherwise, these methods are for forecasting really. So if you have a record of time series and you have a gap on it, then you can use this machine learning, deep learning, or in whatever type of system you can use. But different time series will be different and we end up having a lot of different problems. For instance, we may be familiar with interpolating your data using spline, cubic, or whatever linear, but rest assured, you normally are wrong. And for instance, if you have a complex time series like this one, you end up getting a wrong interpolation if you are using linear interpolation, because the different data is different in terms of its variability. Some of it is stationary, some of it is non-stationary, some of it is seasonal, of course, and so on and so on. So there are many different ways to do this. You may try some of them before you try machine learning, for instance. I like auto-regressive methods. If you want to start with a better method to do these things, I suggest it. You can thereafter merge it with machine learning, for instance. Otherwise, there are many other methods like your methods based on kriging and all sorts of different types. But if you want to know more about some of the methods you could use, you can look at this very nice paper where they summarize all the types of, or not all, but most of the types of interpolation methods you can use. I'm talking about interpolation, but just keep in mind that really this is good for forecasting. But if you can forecast, then it means you can forecast that gap that is there in your data, in your time series. And definitely I know that most of you, or most of us here, do have a lot of issues when it comes to gaps in data, because you have different issues when it with your instruments and sensors wherever you work. So what I did is I took 3 different time series. The time series that I took, one good example is stream flow data, and 2, I took ozone data because of course I'm an atmospheric scientist, and I also took mercury data, atmospheric mercury data. So I have these 3 time series that I want to show you how I designed my own hybrid model to forecast these time series. Nice thing about time series is that you have the truth and you can always forecast and test your forecast using the truth. So the stream flow data that I took is up here from Durban. It's Umgeni River time series. Umgeni River is the main supply of water around this region here of the Durban city in KwaZulu-Natal. Durban is one big city in the whole province. And so they depend a lot on these rivers for water supply and so on. So what I like about the rivers around South Africa as well is that they are well monitored, even though you wish we can do better. So you have a very good time series of stream flow around this area here. So I think you are convinced why I should take the stream flow data and try to focus it. Another data I took is mercury, atmospheric mercury, which is sourced from different places. For instance, from volcanic eruptions, from your biomass burning, but mostly from your industrial activities. It ends up in the air, gets very stable until it is either wet or dry, deposited back into the surface, or mostly ending up in rivers and ocean, and it gets swallowed by fish, for instance, and then you start to eat fish, then it is very toxic and so on. So it is important to look at atmospheric mercury for that reason. And there is a growing community in terms of studying atmospheric mercury because of the issues that come with it, because of the level of contamination you find in water and so on. So this is another interesting time series that I took. You can get atmospheric, or you can get mercury from different places or from different things, like the things that I list here. And the time series that I took is here at Cape Point, but I'm working with my friends from South African Weather Services. We are putting more stations around South Africa, especially around this region here, the Highveld, because of the industrial activities here, coal power stations and so on. When I model the mercury over Southern Africa, I see the strong peak around this area here because of coal power stations and so on. So I use WAFCAM to my atmospheric mercury modeling. And I should also point out that you can actually use WAFCAM to do catchment modeling and stuff like that. There is what is called WAF Hydro. I've tried it and it works also in my computer, even though I'm really not a hydrologist, but there is always that coupling, and then you end up trying to do what hydrologists do. So there's a very nice system called WAF Hydro that some of the students can try. It is very nice. And then another one is ozone. I choose ozone because of the disturbance of the steady state of ozone in the stratosphere. In normal basis, ozone should be created and also be destroyed at an equilibrium in the atmosphere until we as humans come and release CFCs, and then we start to disturb that natural system. And then we have declining of ozone stratosphere. So these are three interesting time series that I test on my own hybrid model. My model is based on deep learning neural network, which is a recurring neural network. It is recurring, of course, because when you consider a normal network, it has a feed-forward system like this, but this one always has this backward, feed backward like this. So is important about that. It means you can always remember what happened in a previous hidden layer and stuff like that. And if you pick one cell, or so the type of recurring neural network that I used is long-term, short-term neural network, which is of course a recurring neural network, which falls under deep learning neural networks. And so if I pick one of the cells here and zoom on it, you will notice that you have your inputs from the previous cell. For instance, this is the YT-1 here is actually the hidden state, and this is the cell state. And every time, and this XT here is your input data. So every time when you feed in your input data, you multiply it with the hidden state output and apply the signet function, and then you get this matrix that will always take you up to this level here. This level here is what is responsible for remembering long-term, what happened very long time ago in a time series. So at this point here, it is where it is deciding whether to remember that or to forget that. And at this point here, it is a point where it considers the importance of what it remembered and stuff like that. So this is where you will consider whether to take that new information that is coming. Otherwise, inside the cell, you have the input that is concatenated hidden layer, also multiplied by your signal function, and then pushed into this one in this state here if you want to go to the short memory of your time series. And this is always multiplied with the CT, which is created by the hidden layer or the input data that is where you apply the 10 function on it, which is really a hyperbolic function, and then you get it, and then you always multiply with this one here, so that you take it to this point where you either forget, or so where you either remember whether that short-term information is important or not. Okay, I just want to pass this part here because it's a long story. Of course, if I had more time, I would like to explain more on the operations inside the cell itself. And this side here is the linear equations that are associated with what is happening inside the gate. I'm sorry, the cell itself. So what I did in my Python system, I sort of take the data, which is I label as original data here. I decompose it, or either not decompose it. If I take it and not decompose it, then it will mean I just take the data and push it into an LSTM and then get my forecast. But I know that, some of you who have done time series forecasting will know how important is it to pre-process your time series before you forecast it. So there are many ways you can do that. You can either denoise the time series before you push it into your model, or you can decompose your time series so that you predict each and every IMF, each and every variability that is inside the time series. So I use 3 different systems here, which are most popular systems in terms of signal decomposition. I use empirical wavelet transform, EWT. I use value mode decomposition. I also use EEMD. EEMD is an improved empirical mode decomposition because there's some issues with empirical mode. I should also point out that empirical wavelet does have small issues because at some point it will not be able to separate between frequencies that are too close to each other. Otherwise, that problem is solved. And in this talk here, I'm just using the normal empirical wavelet transform. So after you decompose your time series, you can then push it into your LSTM. So meaning you're pushing each and every IMF into an LSTM, predict, and then at the end, reverse normalize, or you first always normalize when you want to do this, reverse normalize, and then your prediction, you sum your predictions, and that's your final forecast. So when I talk about the decomposed signal, I'm talking about this. So it means you take your original time series, you decompose it so that you get all these periodicities, and then you forecast each and every one of them, and at the end you integrate them. So this is just an example of one time series that I decomposed using empirical wavelet transforms. You can do the same with empirical mode, or in EEMD, you can do the same with volume mode. I just want to point out that it is for the first time that this value mode decomposition is used in this way. I had never used it before, and the recent improved LSTM is the empirical wavelet transform, but now I have designed in value mode decomposition and stuff like that. So let's start with atmospheric mercury data. This is how it looks like. This is my Cape Point data. I just compare it with the Northern Hemisphere data here. Of course, we have more mercury there, and my Cape Point station is a background station. And what is interesting is that the trends of the Cape Point, or the Cape Town mercury time series, is going up by 0.7% per year. whilst in Europe, you can see this downward trend. So that's it tells us something about our own mercury production here in the Southern Hemisphere. And what you do is that in your time series, you need, what I did is that I divide my time series into 70% of time series that I'll use for training my model, and then the other 30% will be my truth when I have reproduced it. So it means what I will show here is only the part. So if you see here, the time series for mercury will start from 2007. And if I divide that into training part and testing part, then it means my time series will start somewhere in 2014. And so it means here I'm showing only the testing part. So testing part, black is the original time series, and the others are my different models. As you can see here, my value mode decomposition is also performing very well if you put it in a Taylor diagram, and you can see it sits very well with the empirical wavelet transform here, but you can see that the LSTM, when you use it as it is, it does not give you a good performance. And when I denoise or use EMD, you can see it sits somewhere here, meaning these two methods, which have good theoretical background, are performing very well here. So my model performance is tested by your root mean square error, your mean percentage error, and so on. And you can see here, these bar graphs are also comparing the performance of the model, and you can see always you get better performance from value mode decomposition and empirical mode decomposition. I thereafter applied the same on your Umgeni River stream flow. You can see this is how the stream flow looks like, and recently we have a bit of lower frequencies of these higher stream flows and stuff like that. And of course, somewhere here we had a very strong period of rainfall and stuff like that. And somewhere around here, we're drought here because of a strong El Nino. And you can see also here in the sequential Menkedal, it is disturbing around this region because of the dryness. And if you go to Menkedal trends, or sorry, if you go to Thaisen trends of this time series, you will note that there is a reduction of 0.23% per year of data of the stream flow. And when I plot the sequential Menkedal, it will be when I want to see the change detection points in the changes in the trend in my time series. For instance, you'll note that during this time here, there was this sudden change of trend of time series, which was due to the strong El Nino that we recently have. We had a lot of drought here during that period. So if you want to take that time series and take 70% of that time series, use it to train your model, and then take your other 30% to test the model, this is what you get here. You can see most of my models are following on my original data, which is black, and empirical mode is your empirical wavelet. Transform LSTM is on your red, and you have a green empirical mode, or ensemble empirical mode decomposition, and we have value mode, and you can see all of them are quite good in mimicking the original time series. And interestingly here, my value mode decomposition performed very well here with the correlation coefficients above 85% and stuff like that. And empirical mode also performed very well, and the empirical wavelet transforms. So it means these, if you get such high correlations and reduced root mean square differences, then it means the model is performing very well, and you can use these models in sort of closing your gaps and also trying to focus your stream flow, because LSTM is able to learn what happened some time ago, forget it if it is not important, and also learn the immediate input in your data, and include that every time when you go forward with the modeling of the time series. So total ozone column, it's important about this ozone because you get a lot of signatures inside the ozone itself. I plotted growth rate as well, and I also extracted trends of this ozone, and that paper was published last year. and it is the first paper to report on the hybrid LSTM wavelet transform system that uses empirical wavelet transform really. So I did a lot of analysis of the time series, and you get a lot of signatures of volcanic eruptions and stuff like that. And I also showed that empirical wavelet transform can actually give you better trend analysis. And I should point out that mathematical theory of empirical wavelet transform is far better than that of empirical mode. It does not have a good background. Empirical mode decomposition does not have a good mathematical background. So if you focus that time series, you can see all of my models were very good in focusing or in mimicking the actual data, and empirical wavelet transform was actually very good performing. And in this case, I did not use empirical mode, I'm sorry, in the VMD, because at that time I had not developed it. So it was for the first time that I showed that empirical wavelet transforms are actually good in trying to sort out this forecasting issue. So these are different time series which are really, really different, and I tested it. I tested my model. I used everything on my Python, and you can also use this when you want to forecast your soil moisture, evapotranspiration, or whatever time series that you want to use. And if you want to use it with me, then you can come and we can work together. And we are currently doing a stream flow of different rivers from the south of my province here all the way to north. We will select about 10 rivers, and we hope to present that to the Journal of Hydrology. So that's that. Thank you very much. And if you have questions, you can happily ask.
Thanks so much. Thanks so much, Dr. Baba. I think there is time for questions. Vetri, is that the case?
Prof, we can accommodate maybe 2 questions.
Okay, fantastic. Are there any questions? You were just so clear. That's what it's all about.
Oh, that's what it means. Thank you very much. But if you have a question, you can send me an email or.
Hello.
Yes, or someone is asking.
Yes. Thank you. Thank you. Very nice presentation. I'm very interested. My name is Masaka. I'm very much interested in time series analysis.
Okay.
Hydrogeologist.
Okay.
I didn't hear you mention anything about, there's something that I'm interested in, it's called pre-whitening in time series analysis. So I wanted to know whether your method considers white noise and whether it caters for pre-whitening in your analysis. Thank you.
Okay, I think you are talking about time series analysis. Okay, yes. In all my codes, I make sure I include those. First, before I use any time series, I test for all sort of things. Really, that's why I highlight some of the small things like your trends, your this, your that, because it is what I extract after I sort of investigate my time series and make sure I use all these backgrounds so that when I use my time series, I go forward. Otherwise, I do have a lot of time series, not just time series forecasting and prediction, but I have a lot of details about time series itself, time series analysis, because most of the people have problems when it comes to time series analysis. You get it when I give you data and you don't know what to do with it. And so I spend some time really looking at the time series itself. So if you are fine with working with me or wanting to hear more about such things, then it's fine. You can drop me an email. It's fine.
Thank you very much. I think you'll hear from me. Don't be surprised if you get an email from Masaka. Thank you.
Okay, good.
Fantastic. Are there any other questions? No?
I think no more questions.
Okay. Thanks so much, Dr. Mbata. That was really interesting. Vetri, I'll just pass it over to you to move on to session 6. Thanks you so much for all our speakers today in session 5. That was really fantastic.
Thank you so much, Prof. Brian and Prof. CP, to hosting this session. Really fantastic job what you did. Excellent. I'll keep in touch with you. Thank you. Thank you.
Okay, colleagues, without waste, colleagues, we are now going to go to the last session for today, which is session 5. Before I hand over to the chairs, I'd just like to say a big thank you to Professor Siepe and Dr. Chase and all the speakers for a very informative presentation. And then I would like to present the last session for today, which the theme is water quality and the environment. And this session is going to be chaired by Professor Ramathadan from the University of New Delhi in India, and would co-chair Professor Jonathan, who's the professor of National Polytechnic Institute in Mexico. Before I hand over to the two chairs, I would like to invite Brian Rollins to immediately after the last speaker and when the chair is handed over or concluded the session, to please give the closing remarks for this conference. I just don't want to be wasting any more time. If once they finish, Brian, if you could just come in and do the closing remarks. Thank you. And over to you, Professor Ramathan and Professor Jonathan. Thank you.
Okay. Thank you, ma'am. Professor Jonathan, you're here?
Yes, doctor. I'm here.
Okay. Welcome to this last session on the water quality and the environment. Myself and Professor Jonathan from Institute of Polytechnic. I am from Jawaharlal Nehru University, New Delhi. And we have water quality and the environment, which is very important because the quantity is also deteriorating and quality is also, quantity is reducing and quality is deteriorating because we are, our environment is no more pristine everywhere, including Arctic and Antarctic. And so it's very important aspects that we are finishing with this topic, this important webinar. And we have, I think, 25 minutes for talk, for each talk, 20 minutes and 5 minutes for the discussions. So we have 5 talks, I think, 1, 2, 3, 4 talks now. Jonathan, we'll start the program?
Yeah, you can start, sir.
I will request the first speaker, invited speaker, title of the talk, Professor Serban Proches. Are you here, sir?
Yep, I'm here.
Yeah, welcome, sir. Welcome to this.
Thank you.
We are going to talk about important one, climate change in the tropics. Why less is more? Very nice topic. And can you start, sir?
Most certainly. I will start sharing the screen right now. And can you please tell me, first of all, if you...
Yeah, we can see that.
You can see the screen. Wonderful. All right. So, yes, good afternoon, everyone, and thanks for hanging in until this presentation. And thanks to Vetri and to everyone for a very good lineup of speakers. So, essentially, I'm a biologist. I come from a biology background, and I've been in a geography department for 13 years now. So much of my work to this point is essentially biodiversity and biogeography. I do have a strong component having to do with climate variability, mostly in my teaching, but also to some extent in my research. And I'll quickly review what I did that has to do with climate variability and the impact of climate variability on biodiversity. So I'm originally from Romania. So I started being interested in biodiversity and in climate in a temperate country, very much a temperate country. Then I moved to South Africa, and I was based in the Cape for a while, and I was looking at Mediterranean type vegetation, which is subtropical. And we heard earlier from Brian quite an interesting story about how with the glacials and interglacials, things actually shift up and down, and how this type of subtropical environment can switch quite dramatically. But my current research, and you can see here on the map to the right, started in temperate, moved to subtropical, and currently my climate-related research is actually in the tropics. It's based in Southeast Asia. So I'll quickly run through my climate-related projects, and then I'll get to the key question of climate change in the tropics, and why exactly is it less, and why exactly I think it's more, and it's also more exciting. So yeah, I started back in Romania at the University of Bucharest. I was looking at patterns of endemism in the Southern Carpathians. So this was back in 1999. And I was linking the patterns of endemism to the past glacial maxima and where there might have been climatic refugia, where these endemics might have survived. And this work is being nicely followed up on in Romania, amongst others, by my colleague Bogdan Hurdu, and to a great extent also throughout Europe, with contributions from the Kew Botanic Gardens and from France and so on. And then in the Cape, the first project that I looked at with my postdoctoral host, which was Professor Richard Cowling, and also with Derek Dupria. So we looked at the representation and diversity of geophytes. Now, geophytes are plants that have a storage organ underground. So they store water underground. And they're very diverse in Mediterranean type systems throughout the world. And what we were trying to figure out is how climatic variability and climatic reliability actually promotes the diversity of geophytes. So if you're looking at the yellow transect on the map from Cape Town up into Namibia, very similar to something Brian was talking about earlier. So you can see, if you're looking at the two bottom graphs, you can see that on the left, we're looking at the amount of rain, and the amount of rain is varies dramatically. So as you go into the desert, of course, it drops dramatically. But bottom right, what you're seeing here is seasonality. And the seasonality is practically the same. So you get winter rain all the way from Cape Town to the Namibian border. Now, if you're looking at the red transect from Cape Town to Port Elizabeth, things are very different. So the amount of rainfall, which is the top left graph, it kind of fluctuates as you move from west to east. But what you see as a clear pattern here is top right is the seasonality. So you're moving from a reliable winter rainfall to some sort of spring and autumn double peak in the Port Elizabeth area. And essentially, we show that geophyte diversity is influenced to some extent by the amount of rainfall, but even more so by rainfall reliability, which is unsurprising, because if you want to put out flowers in summer when birds and bees are moving around to pollinate you, then what you need is you're going to need some water to produce those flowers, but there's no water. So basically, those plants that are capable of storing that water from the rainy season, which is winter, then you've got a job as a geophyte. And then together with my master's student at the time, Stefan Helemann, who's now back in Germany, we also looked at how the combination of rainfall reliability in the Cape with fire seasonality, how that influences the success, the reproductive success in proteas. So that was my work in the Cape. And then later on, in a project led by Richard Cowling with myself and lots of other people, we looked at how climatic reliability and topographic reliability influence plant diversity throughout world's Mediterranean climate systems. Essentially what we're saying is reliability is good. So the Cape and Australia, Southwestern Australia, which have high reliability, they've got high plant diversity. But there's also an element of how variability, especially slow climatic variability, can actually promote speciation. My current work that has to do with climate is based in Southeast Asia, and I'm working with my colleague here in Durban, which is Sid Ramdani. And I'm also working with Alice Hughes from Sichuan Botanic Gardens and Liam Ping Ko from National University of Singapore. And one of the things we're finding is that when you map the diversity of ancient lineages worldwide, you see the map bottom left, there's a very clear peak in South China and North Indochina. And we're relating this to the monsoon systems. We've actually got 3 monsoon systems in South and Southeast Asia, which kind of converge over this area, and presumably that offers a bit of climatic buffering. I listened with great interest to the presentation of Prof. Dimri earlier about how that might change in the future. Is it all about monsoon systems? It's probably not. It probably also has to do with the course of the rivers in this area. So you've got these 3 major rivers, all of which are running north to south. And that's a very nice way for a river to go if you're a plant or an animal, because as the climate changes, you can actually move up and down the valley very nicely. Whereas if you get west to east rivers and climate changes north to south, then you've got nowhere to go. You can move a bit altitudinally, but then you're more likely to go extinct. So that's just a summary of my climate-related work. Now I'm getting to the question of this presentation. How exactly is climate change in the tropics less? Well, you're probably familiar with this type of narrative of climate change. Pictures of polar bears marooned on some little piece of ice that's left in the Arctic Ocean, and preferably a bit of garbage all around it. And it's understandable how this comes about, because to the present day, the change in climate that we have seen through the anthropogenic period is most dramatic in the Arctic, and it's also fairly dramatic in some other maybe temperate parts of the Northern Hemisphere, like Europe and the Middle East. And this is projected, with some changes, to continue along the same lines. Now, if you're looking at this map, can you say, flat and clear, there's more climate change in cold and temperate regions compared to tropical regions? My answer would be no. So there's a lot of variability in temperate regions. Southern temperate regions actually have less climate change than the tropics. There's a lot of variability in the tropics. So we need to actually look a bit beyond these simple maps of average temperature increases and projections, and just look at some present-day variables and see where the tropics are less, and are they truly less? And this is one of the variables that you'd all be familiar with. It's just air movement. And of course, that's there's a lot more of that in temperate areas, both above the sea and above land, compared to the tropics. So that's a commonly known fact. There's less air movement in the tropics. And that, you know, the air movement is actually critical to how biodiversity hangs around, increases or decreases over geological periods. And I'll get back to this, and I'll try to get to the point as to why this particular less is not really less, but in some ways actually more. So how is it more? How is climate change in the tropics more? I mean, there's also the socioeconomic side, which I'm not going to go into because I'm not an expert in that side, but you're all familiar with issues of climate change that might actually impact far more dramatically the tropics in a socioeconomic perspective. But from my point of view as a biodiversity researcher, you just look at a map of species diversity like this one, and things are very simple. Biodiversity is higher in the tropics compared to temperate regions, and even more so compared to cold regions. And the argument for a long time has been, well, you do get more species in the tropics, but they like it hot. So it's going to be a bit hotter, so what? And the turning point was actually this paper led by Curtis Deutsch. And his point was very clear. It's true, the species in the tropics like it hot, but they're only used to experience daily or annual, let's say annual temperature variations of maybe 15 degrees. So maybe temperatures may vary between 15 and 30 degrees in many places in the tropics. Whereas in the Arctic, you get things between -30 and +20. So you could actually end up with a whole 50 degrees range of temperatures that these animals have to put up with. Can they survive another 2 degrees? They probably can. Sure, there will be changes if all the ice melts. That's beyond the 2 degree issue. But overall, animals, and especially ectotherms, so animals that cannot control internally their body temperature, they're more likely to be affected in the tropics. And that's quite a sad story to tell, because that's where most species are. So we've got an excellent review, actually published last year by Kimberly Sheldon from Tennessee. And she's basically telling this whole story very beautifully of how climate change in the tropics will affect the biota potentially more, in what ways. And she's got very nice summaries in terms of impacts of climate change on biodiversity, on phenology, and all sorts of other variables. The issue I find with this main narrative about climate change, well, there are two separate issues. So the one is there's a bit of circularity in it. So first of all, how did we end up with less diversity in cold and temperate regions compared to the tropical regions? And a major factor there are glacial maxima related extinctions, and the extinctions relating to the shifts between glacials and interglacials. It's an extinction-driven process, rather. So now, if we're telling a story whereby the changes in temperature will also be higher in temperate regions, how does this differ from what happened in the past? And of course, we do hear the part where they say, well, it's getting off the charts. It hasn't been this hot through the latest few interglacials, so we're going into uncharted territory for most of the species. The second part, which you see less of in the media, is the fact that also looking at a world where ecosystems are very fragmented through different anthropogenic effects than climate change. So things are not as likely to move around. So we need to see the difference between past climate change and the generation of the current patterns in biodiversity and anthropogenic climate change. We need to break that apparent circularity, which is partly correct. And that partly correct part is quite dangerous. Now, the second issue is, I mentioned extinction, but there's more to it than extinction. So we're also talking about speciation, because the narrative for a long time was the tropics have more species because they have low extinction and higher speciation. And that hasn't been really argued against in a climate change perspective very well, although the evidence is there, starting since about 2016, that when all other things are equal, speciation is actually higher in temperate regions And that goes with our findings in the Cowling et al. Paper, where we say you need a bit of instability. As long as it's a tiny bit of instability and it happens slowly, that promotes speciation. So there's a lot to be said besides this common narrative of climate change, greater in temperate regions, lesser in tropical regions. There are multiple effects to consider there. And I'm getting back to the global atmospheric circulation, which I mentioned in a very simplistic way. But that simplistic way is the map that one learns in school, and you don't really go beyond that. You need to go and split that the way they did in this paper. So that's Xu Zhuanghu from Lanzhou University and her colleagues. They did an exceptional job of actually splitting this atmospheric circulation into three major components, one of which has to do with the whole El Nino La Nina effects. And it's interesting, but that's more like a puzzle to solve. But to me, the key is to understand meridional versus zonal circulation. We need to start with the basics. And paradoxically, we don't actually have a regional understanding of how zonal circulation impacts biodiversity over thousands and millions of years. And you need to go back to the thousands and millions of years in the past to understand how it might go over the next century. So what do we do from here? Where do we go from here in terms of enhancing our understanding of how climate change impacts biodiversity in the tropics? You need to look at this whole framework. So on the one hand, you need to look into the past, and is this sort of work that that Brian presenting that actually gives you great insights into how things happened in the past. And also it's nice to see that the recent paper by Stephen Sherwood, where I showed you the map with higher increase in the Arctic and lower in the tropics. That study comes a bit closer to reconciling past climate change with the projections for the next century, and that's great to see. But the other side is these three blue blocks at the bottom is having a baseline understanding of what is happening now, what influences biodiversity now in the world. And you know, there are thousands of studies looking at it. But I think in a climate change, and especially in a tropical climate change perspective, we actually don't have a great baseline understanding of the other climatic variables, climatic variability, and how biodiversity responds to that, how other anthropogenic changes impact biodiversity. And especially how do these sorts of data availability in these respects, how does that vary between the temperate regions and the tropics? And especially how the metadata and variability data associated with the sort of data varies between temperate and tropical regions. You know, I often get asked by my students, has any species actually disappeared because of climate change up to the present day? I think the short answer is yes, but the problem is that we've got so many confounding factors that it's not easy to give a neat answer. So you're looking now at the golden toad of Costa Rica. So it lived.
Professor Serban, it is 20 minutes.
Okay, I'll try to wrap up. So the golden toad used to live in Costa Rica at about, you know, not at sea level, at some altitude. And when it went extinct, it coincided with an increase in temperatures around that altitudinal belt. But it also coincided with the arrival of the chytrid fungus, which is a major disease that hits amphibians around the world, and which actually causes greater effects at higher altitudes compared to lower altitudes. So it's one of those confused cases. And talking of baseline studies to understand biodiversity impacts, anthropogenic, not just climate. This paper by Francisco Sanchez Bayo and Chris Weikheis, 2019 paper, it's possibly the one science paper in any field of science that caused most waves and responses over the past 2 years. So basically what they're saying is insects are declining throughout the world. Insect abundances are declining throughout the world. And there have been tens of responses, all sorts of papers saying they didn't do their homework, their stats are wrong, so many things they found wrong with the paper. I think after all this, all these responses, the dust has settled, and the short of it is, they're actually right. Insect abundances are decreasing around the world. They may have not done things ideally, but just look at the map. Where do their data come from? Mostly Europe, to some extent North America, practically nothing else. Right? What can we say about the tropics? And we have to go to the work of Henk Wolda from the Smithsonian Tropical. If you look for data on insect abundance variability in the tropics, the best papers are from the 70s and the 80s. Nothing on that level has been done recently. So no surprise, this dude is one of my heroes. I mean, he did single-handedly, look at these papers, single author papers. How many of those do you see these days? Something that hasn't been repeated since. And just 2 more studies I'll quickly present. So this is, you know, biogeography is fixated on tropics more than temperate and fixated on area, big islands, more species. This paper by Christy Udli from Georg August Universität Göttingen, she's basically saying heterogeneity is more important than area. And heterogeneity is essential because climate refugia are typically places with high levels of environmental heterogeneity. So,
Professor Selban, I think only one more minute left, please.
1 minute and I'm wrapping, thanks. And also what you can see here is the great amount of unexplained variation in the tropics. Right? And the last paper I'm going to speak about is by my collaborator, Richard Cowling, and he's basically studying variation in species diversity in the Cape. And you can see there are longitudinal patterns, and these are associated with zonal circulation. So we need to look at all these other things, zonal circulation. We need to look at key taxon lineages and refugia and understand how they respond to climate change, to understand biodiversity impacts in the tropics. So thanks to the organizers and thanks to everyone who funds my work and who funded this conference. Thank you guys for your time.
Thank you, Professor Selban, and it is really interesting. You brought out a lot of things in the tropics and compared to the temperates. So any one quick question, if it's there, we can take it. Otherwise, anybody is there to want to ask? Or okay, nobody is there means I just want to ask you. You have been look into the little ice age anomaly in the tropics after the interglacial period.
No, I've never looked at that, but it does sound like I mean, of course, it's the greatest recent variation that one could actually pick up things from. Yeah. It's a great idea. No, I haven't.
Okay. Thank you, Professor Selban.
Thanks.
Okay.
Thanks.
Thank you very much. And may I request my co-host, Professor Jonathan, to give the talk.
Thank you, Professor Nathan. And I hope the slides are visible.
Yeah, visible.
Good evening, good afternoon, and good morning to the American continent, because we are connected from 11 a.m. the South African time, and many from Colombia and some of the known colleagues are also connected from the American continent. And for the Asian region, it might be a little bit late, but anyhow, we are in the world where it is temporarily closed. And as you see the topic, it's I would like to state that I am from an interdisciplinary center where we have all disciplines mixed, and we have all the studies related to different themes. So my talk will be a little bit mixed talk with all disciplines, and mainly with COVID, because we know still now Mexico has not lifted the lockdown, and it has lifted, but but again it closed in December, and we are shut down for another 3 months, and till February 15th, I think, or 20th, I think, is closed completely for the second and third wave. So we know very well how this COVID or the last year, it affected all over the planet. And I would like to stress and I would like to bring out some of the important features where it affected the environment. And in some places it was advantage, and some places it changed drastically, and some places it went to the old level. So let us see. There are many research articles. There are many things which were done during last year, and this will be a completely review talk. And it some of we have done some work, but still now it has not yet been published. It is on the process, and you know the laboratory and other facilities all are shut down, so it's going a little bit slow. Anyhow, I will try to explain some of the information which is available uh, by the various researchers which has been done, and so that we can know where we stand and how this pandemic has affected all over the planet. And the first one, some of the videos which you might
What we have done together over the past few months has been nothing short of remarkable.
In BBC.
Billions are home, our metropolises are empty, the very transportation hubs many point to as poison for our planet are now vacant. So too our centers of commerce are silent. If you're looking for hope that a more balanced relationship with our planet is possible, these actions have made an immediate and discernible difference. Satellite images from the European Space Agency show air pollution has subsided in cities across Europe. Madrid, Rome, and Paris all saw significant decreases in nitrogen dioxide, decreases of up to 45% in some places. According to the publication Carbon Brief, emissions in China fell by a stunning 25% in the first few weeks of 2020. With factories and offices shuttered across Europe, energy consumption is down, way down, double-digit percentages in some countries.
If the economy stays slow, if transport stays down, we could see a drop in carbon dioxide emissions this year of 5% or more. And that may not sound like that much, but we've never seen that in the past 75 years, maybe going back to the end of World War II.
No one has ever seen mass transportation change or stop so quickly. Air travel around the world has evaporated. Last year, TSA handled an average of 2.5 million passengers a day in America. This month, it's 90,000 a day. Crude oil prices have crashed. We've literally extracted from the earth more than we can use or can store. Oil prices on Monday were considerably cheaper than hand sanitizer. The reality is, as quickly as we flipped the switch off, we will likely flip it back on.
It's not going to last that long. So as soon as everybody gets back to normal, these emissions are going to start, unless we decide to do something different.
Until then, some wildlife will enjoy the short-term, unprecedented cessation of human life outside. Penguins are on the move in South Africa. Goats, possibly now in charge of this small town in North Wales. Pigeons are pack hunting in Spain. And the waters of Venice are as clear as they have been in a generation. Now, politicians like Governor Cuomo have said we can't go back to the way things are. Rather, we need to move forward. And we've seen that the way we're living has a discernible impact on the planet. So the question is, as we move forward, are we going to enact policies that focus on sustainability, or will we go back to our lifestyle of consumption?
So based on this video, you can recollect what has happened all over the planet. So you see the changes in the atmosphere, changes in the water, changes in the animal behaviors, and changes in the coastal region, and changes in the energy, in all the sectors from top to bottom. It has affected each and every one. So let me signify, or let me show some of the evidences which some of the researchers have documented. First one is the emissions in the atmospheric layers. The CO2 emission has changed drastically in many places. And the first one And the first one in, in the US, in the American side, you can see how the traffic was less. And this is not alone in US. It affected all over the world. Or you can say that it's the air traffic has come to a standstill, came to a standstill for nearly 3 months all over the world. In New York, it reduced to 50%, and Seattle, it reduced to nearly 40%. And like this, when you see in China, where the virus started, the air quality in some places have improved when during the lockdown, the carbon emissions fell by 25%. And in some cases in Europe, where there were very less passengers, the flights were empty, and it was almost empty flights flying up and down. And there was also decrease in nitrogen dioxide in Spain as well as in Italy. And when you see the April 2020 um, image, which was published during the for the ozone hole, it it is not related to COVID, but even though it is not related, you can see the difference, and scientists still now are thinking whether it can be related to COVID or it is due to the changes to the ozone hole, which finally closed for nearly a month in the Arctic region. Still now, this is a question, and it is not yet confirmed. This is a famous imagery which many of you might have seen, and many of the people who are working in the atmospheric sciences might have seen, where the NO2 scenario in China was almost reduced to zero during the lockdown in February. And this is the NO2 emission scenario in Wuhan. You can see on the top, you have the January 2019, and below that in the blue, you have the mean troposphere NO2 of February during the lockdown, where it is almost zero in the blue color, especially in Wuhan. Like this, in many cities, it happened. I would like to bring out some of the information published by leading researchers. This is one which came in El Salvador, where they took different cities, major cities, that is the New York or Mumbai, Spain, as well as in Italy, as well as some of the European cities, where you can see the PM2 level, 2.5 concentration has reduced during the lockdown. And the next one is the Italian case, where you can see how it is related to the long-term air quality data can correlate with the spread of COVID-19. And this is also a very good information which came in environmental pollution. And the next one, when we see the changes in fresh and saline water, you can see this changes in Arctic zone. And still now, they are debating whether it is directly related to COVID or it has some relation due to the lockdown. You can see the Arctic meltdown, or you can see the Arctic or the glaciers. Maybe Professor Ramanathan, who is the chair for this session, can inform or give some information about this aspect. And everybody, we do understand that the CO2 in atmosphere will remain in the atmosphere for decades. And this warming will continue for a long period. Whenever ice disappears, often it exposes the dark sea water and dark land. The white ice normally reflects the sunlight back to the space and keeps us cool. Where the dark land, the dark water absorbs and turns it into heat. And when the ocean water gets warmer, often the ocean currents melts the permafrost. And as we know, the organic materials also give up the methane, which is more pollutant than the CO2. And we will see now how our technology has been dirty during the past years. We are talking about advancements in technology, but now you will see how it has been dirty, and we have to think where we are going from this part. And this is modeling for the temperature, where you see the hot air temperature moving towards the polar regions, both on the north and the south, where in the coming months or the coming years or in the coming decade, you can see more melting of the polar ice. And during May 2020, there was a news in CNN where it showed that it was the hottest month for nearly a decade, and it was reported by the European Climate Agency. And this can be compared in different aspects. And during the month of June, the German research vessel started an expedition to check the emissions of the CO2 level, and they nearly found out the biggest drop which happened since the World War II. So you can see how it has changed, this particular COVID or this pandemic, how it has changed the climate in different parts of the world, not alone in atmosphere, but all along the water and other aspects also. When we compare to the temperature, this is a study in Brazil, and when we see the temperature, it was related to nearly 25.8 degrees centigrade, which became flat and above, and this was supported by the case count. And we could also see the decline of weather becomes warmer in temperature above 25 degrees, 25.8 degrees. There was a Cuban study. There was a study in Cuba, and this was also reported in a journal of medical virology, and how the mean temperature outlook for the Caribbean during the month of March and April, May 2020 has been related to the death of the COVID.
Hello.
Yeah.
Yeah.
I'm able to.
Yeah, you are another 2 minutes.
And the next one is the COVID, the Galapagos Island. You have the nearly all the beaches have improved, and there was less plastic. And when you see the noise reduction also played a major role, where you saw 72% smaller fishes and 17% have humpback whales. And this is a surface water quality where you have low SPM, suspended particulate matter. This is from Bembad Lake, from the southern part of India. And the highest was in February, and the lowest was during the April. And this is a video where all the human movements were seen, were locked down, and animal movements were seen. And this is an image from the Acapulco beach in Mexico, where bioluminescence process started during the lockdown period. And this happens occurs via the marine vertebrate and invertebrate and in some of the fungi. And here you can see some of the whales which were very close to the ocean, and this was reported from the Atlantic side as well as from the Pacific side. This was reported in the BBC, and this was also from the BBC. And here you can see the changes in the coastal groundwater, where the fecal coliform activities was very less. And this was from the southern Indian city of Tuticorin, and where you can see also the nitrate NO3 concentration also. There was a decrease due to the decreased use of farmland manure. And the effect of waste and plastic. This is a famous picture which many of us might have seen after the usage of face masks, where you have a single, where you can see the increase of municipal solid waste, especially plastics, and also the consumption of energy was also more in household activities. And this is the changes in the habitats. And here is a small video which you can see where the changes was observed. And this is what from the whales and other dolphins which were seen close to the Mexican coast due to the reduced tourist activities. And the final message, I didn't run the previous videos, but this one is an important message which I would like to inform, or you can just
Why did the generation before me leave us with a lot of environmental problems?
Where is the action that was once promised in spirit? There's so much power the world has, but we just don't do anything.
This isn't just us we're losing, this is future generations, the planet as a whole.
For me, this is not a problem that will only affect our future generations, but one that affects me now.
Why?
Why?
¿Por qué?
My question to the United Nations is, why? Why do you sit here and pretend and do nothing?
Why do we continue doing nothing when these drastic weather changes are already claiming the lives of people?
Why wait until it's too late to stop using fossil fuels?
Why do we continue to scour the globe for the last of the dwindling resources?
Why don't you take more action? What are you leaders afraid of?
The environmental issues that are most important to me, for one, it's the drought.
The dredging of the Great Barrier Reef, the deforestation in Tasmania.
The dam that provides my city with water is predicted to be drying up by next month.
All these organisms are becoming extinct.
Com a floresta amazônica sendo destruída, muita pouca umidade vem aqui para a região sul e sudeste, então provavelmente daqui a alguns anos a gente passa a ter pouquíssima água aqui.
My dad wanted to try put a wind turbine in our garden. The council said, no, it doesn't look pretty enough. If we actually want to try make a change, you've got to help us try make a change. When my generation grows up, we may not have the time to hold summits about climate because it will have already affected us too much.
To the leaders of the UN, I would like to ask,
why not?
Why not?
Why not?
Why not come up with region-specific solutions?
Why not?
Make the change to clean energy.
Why not focus on increasing the efficiency of renewable energy sources?
Why not inform and engage the students of this generation to act upon climate change?
Why not give tax benefits on green energy?
Por que não criar programa mais forte de proteção ambiental?
Why not be committed to a future for your people? Me and the whole next generation are counting on you.
Why not now?
Why not now? Why not now?
And the next one, the second message which I want to share is the.
I think Jonathan.
Yeah, tell me.
Can you close it because two more
talks are there, and the last
more
one.
Speakers are there. We have exceeded the time.
15 minutes, okay. And the last one is just we should know how we have to be vaccinated, and let us break the chain of spreading. Thank you very much. And this is a book which will be released shortly, which we had worked. And the last one is you have the email ID.
No, you are not showing. Your only video is coming. You are not showing anything.
You have to stop, no?
I have to stop. No, fine. Yeah. But I thought you were showing something. Okay. It's nice because this COVID and environment is very important, and unfortunately we don't have time. And he's right that we are bringing out a book on the COVID impact on the environment. I think soon it will come. And next speaker is Professor Pedro Francisco. Are you ready, sir?
How are you?
Yeah, it's nice meeting you after a long time.
Yes, Dr. Jonathan have many things to say. Hi, Dr. Jonathan. Nice to say hello.
Okay, sir. Start, sir.
Can you hear me now?
Yeah, you can hear it. You can start, sir.
Yes. Okay. I'm start. Okay. Let me say this. Okay. Thank you very much for inviting me. It's an honor for me share some aspect about the hydrogeochemistry and isotopes in groundwater. In the view is the tools for sustainable. The case study is in Puebla Valley Aquifer. This work is combined to work with the Dr. Chidan Balan. Hopefully is on the whole. Let me introduce you some the index is some introduction aspects, study area, background, fieldwork, methodology, results, and conclusions. And the results is clever for the hydrogeology, bottom, and stable and not stable isotopes. How we can do it? What we can know? What we want about the society, specific for the water and more specific for the groundwater. How the decision makers can be regulate the water consumption and treatment? We needed the information, and the information is very important. Is the quality and quantity. How we can do it with that? We can construct public policies. But what need for these public policies? The information about this: how much water we have, for how long, and what quality this water has. If we have very good response of that, we can sustainable environment and water security. But what happens with the information is not right or is not complete. Probably we have a non-sustainable environment and no water security. Let me review some of the concepts. What about with the quantity? The quantity depended to the meteorological regimen, conservation of the recharge areas, and the hydrological recharge and discharge. The time of recharge of the aquifer depended directly for this confined or not confined aquifer, and depended what is the depth of these aquifers. Can be say days, years, centuries, or millions. What happened with the quality? The quality depended for the type of rocks of sediments in the aquifer. The time of the groundwater has reminded in this aquifer and the structure geology of aquifers. When the aquifer is fractured or filed, the water contained deep aquifers lead into the upper aquifers, compensate the water extracted in the shallow and intermediate aquifer. What has happened with the anthropogenic impact? If the anthropogenic impact introduced to the contaminants to the aquifers and go back for the recycle. What about with the important aspect of the over-exploitation of wells? When the over-pump an aquifer, we create a cone depression with many cases unrecovered. Let me tell you for the study case. This is the evolution of the construction of the Aquifer Valley Aquifer in Puebla. In the beginning for the many other aquifers in Mexico, beginning for the calcium carbonate strats, layers, then after to the activity volcanic for the Mexican Reverse Southwest, for example, and increasing the activity volcanic and the construction for the outer layers with the sediments and alluvium and sediments and volcanic. This is we recent publication in the Journal of Hydrology. This part of this information of this lecture, and again this combined for the Chedambaran professor. This is the tree model of the city Puebla of the aquifer. We have 3 layers. You can see very good. This is like a stadium. Look at this is the Popocatépetl and Iztaccíhuatl volcano, plateau of Tlaxcala Plateau, and the other volcano Malinche. Look at the important thing is, look at this in this area. This is Puebla City, and this is Tlaxcala City. This is more or less 4,000 square kilometers. And this is D, and this is C. D is exactly the Valsequillo fracture, and D is the fault of the Valsequillo. We have a fracture. This is a short story for the sediments of the suspended soils. Look at this is the suspended soils in the history is increasing. Recently, this is we are close to the 100,000. This is the very recent for the 2016, and we have more to 2,000 milligrams per liter. This is the short history for the economic pressure. The economic pressure is 1996 and 2002 is increasing very fast. Recent information published in the Environmental Earth Science. We have 3 wells with several scenarios for the depression cone, and all of this is increasing. This is our study area. The green balls is the circles, is the sample area, and the orange circles coming from the sample for the isotopes, stable and not stable information. In the methodology, we sampled 100 groundwater wells, the laboratory determination, physicochemical, inorganic ions, hydrogeological, radiocarbon stable, and isotopes, elements, rare earths, more than 100 parameters. Construction of sequential spatial geostatistic and integrated structure geology for the aquifer in Puebla City and correlation with the presence of the boron. This is look at this is the walls close to the Popocatépetl, into the city, and between the city and the rural areas. This water is the main supply for water for the population of more than 2 million people. This is the Piper diagram. We can see very well, very good 3 groups: circles, triangles, and squares. This is the magnesium sulfates, calcium bicarbonates. Here, look at this is the first group, second group, and third group. This is, in other words, the water acquires the properties of the rocks and sediments. It is contained through different processes, including dissolution and weathering. We have the 3 groups, the first one and the second one. This is the transition of the first to the third group. This is the Puebla City. Look at the geographical distribution of the triangles is for the east part, preference and south, and this is the squares is for the other side and the south, and the circles is preference to the center. This is the principal component analysis. This is a contribution specific for the Dr. Chiran Balan. It's very, very clear. We have the 3 groups here, 1 group, 2 group, 3 group, the third group. This is all of the groups share properties, geochemistry properties. Each of one have a very specific properties, and combine in between the different groups, different in geology, in geochemistry characteristics. This is the saturation of in the case of the anhydrites and gypsums. That is, the water of the group 1 is enrichment with the sulfates in the flow into the higher aquifers. Go up and enrichment for the sulfate. The sulfur converted in sulfate. This is the map of the boron. This is remember the cross, the fracture on 5. This is exactly here. This is close to the downtown of Puebla, and this is the concentration the isoisotope concentration of boron. This is over to 5,000 micrograms per liter. And in the isotopes, stable isotopes, we correlation, this is our samples is a small and brown volcanics is here. And we can reconstruction the paleo-environmental conditions. This is the correlation with the periglacial events this is the moraines in the stage 1, 2, 3, and 4. We have another one, 5. And we correlation with the paleo temperatures in the reconstruction for the Heine in 1973. We can see very good the different stage of the temperature to cool or hot. This is the approach for the zoom for the moraine. The moraine is date with the date for the calcium so the carbon 14 carbon radiocarbon, and this is the different fabric for the size of fabric for the sediments, and we can detect it very well around to the Malinche volcano and Popo volcano and Iztaccíhuatl volcano too. In this figure, we can see the reconstruction for the 35,000 years ago. This is the M1, M2, M3, M4, and M5. This is the 1,000 years ago. We have the very good correlation with our data. This is the radio ages. This is the isotopes, stable isotopes, and this is the stage of moraines. What does mean that? We can deduce that the development of the volcanic topography controlled the geometric of the basin and contribution the volcanic detritus sediments forming the aquifer, while the glacial episodios contributed significant amount for the water in the infiltration to this aquifer. Let me discuss these results, specifically for the sulfate concentration boron meteorologic line and radioisotopes for the radio H's for the radiocarbon. This is discussion going for the basin of Mexico City. Mexico City basin is neighbor for the aquifer valley. Remember this is the anhydrites. Edmunds in 2002 found the same concentration very close to the volcano de Popocatépetl. This is like to the mirror image. The boron concentration we find, the Edmunds find exactly in the same place for the other in the other side. The correlation with the line meteorological line is the similar for the concentrations for the Edmund, and the radiocarbons discussions for the isotopes, stable isotopes, and radiocarbon for the stage of N4 and close to the N5. Edmunds find to this part exactly in the same ages. What is the conclusion of that? The quality of the water in the wells of the Puebla city of Puebla reflected a complex regionalization which is conditioned in the mixing of the underground water from the deep aquifer to the shallow aquifer. The presence of boron in the crossing to the fault and the geological fractures in the aquifer system of the city of Puebla suggested the presence of the geothermal activity probably promoted for the deep intrusion. The quantity and quality of groundwater in Puebla Valley aquifer is depleted and the quality is deteriorated. The sustainable management of the resources going through a difficult situation, and the hydrogeochemistry in the isotope information can be modified and dictate a new public policies for the exploitation of the groundwater resource in Puebla, Mexico, and many parts of the world where this resource is exploited. Thank you very much.
Thank you, Professor Pedro Francisco. And any question from the audience? Okay, Pedro, nice presentation in Puebla Valley, the water quality. So
Thank
do you
you.
have, and do you have any data to show from the past to the present? Maybe 10 years, 20 years before what is there and now what is the water quality and quantity?
Yes, the approach of this water quality is a correlation with the exploitation of water or groundwater now in Puebla. What is the important? The important is this information for the large time for infiltration of this water. Like Dr. Ricardo say in Sao Paulo, it's very important to know and included in the public policy, sustainable public policies. For this reason, is the process, the method, the weathering, the dissolution. We are converted good water in pre-treatment water for the houses and industries and the public.
And you are in your earlier you showed one Piper diagram and later you showed both are in the same valley.
Yes, this is for the same valley.
So sulfate is in one, it is high, it is towards the sulfate, in one it is not towards the sulfate. That's why because the sulfate is high in one of the Piper diagram, in another Piper diagram it is in the carbonate.
Yes, this is the one diagram is for the Mexico City. The basin of the conditions is just a little bit different. Is different, the geology and the confine of the aquifer. And the other one, yes, is for the aquifer of Puebla.
So this is
Yes,
better
different.
to get the carbonate one. Huh? Carbonate
Yes.
one can manage. Okay. Very good,
Yes.
very good. Very nice, and paper is good. Journal of Hydrology. That's great. And
Yes, we constructed with the Dr. Chidan Malan, and I say here, hello, doctor, and thank you very much for this collaboration.
so anybody, any other question for Professor Pedro? I think everybody understood nicely. Thank you very much, Professor Pedro. Thank you.
Thank you, Dr. Ramanathan.
Hope to meet you and sometimes soon. Okay.
Yes, we need to collaborate because it's coming more wells for study in Mexico.
Yeah, thank you. And next, may I invite Professor Abner Patton? He's there? Dr. Abner Patton?
Yes, he is there.
I'm here.
Welcome, sir. Welcome, Dr. Abner. And
let's see. I believe I'm on.
yeah. You can project your presentation, sir, on the reservoirs preservation.
This is reservoir storage capacity preservation by implementation of best management practices. Is everyone on board?
Oh, are you projecting your slide?
Let's see. I must not be.
Yeah, it's now visible.
Now we're good?
Yeah, good. Go ahead.
The presentation is a very simple and cost-effective mechanism for preserving reservoir capacity. Here in Tuscaloosa, Alabama, we're in an area that receives significant rainfall on a yearly basis. For example, in 2020, we received 66 inches or over 1,600 millimeters of precipitation for the year. And because of that much surface runoff, there are issues with sedimentation of reservoirs. The city obtains its water supply from Lake Tuscaloosa. When a reservoir is constructed, the largest storage capacity is at the time of completion. And as soon as it's completed, capacity is being reduced due to sedimentation. In simple best management practices can be implemented and reduce significant amounts of sedimentation. This is Lake Tuscaloosa. This is the city of Tuscaloosa down at the bottom of the screen. Here's the dam to Lake Tuscaloosa, and the lake runs up all the way up to here. It's a long, narrow lake, but it is a significant lake. It was completed in 1970, and it's over 5,800 acres in size, over 20 miles long, and it has an earthen dam, and its original capacity was 40 billion gallons. Subsequent bathymetric surveys have indicated that over a 34-year period, the lake volume that's been lost due to sedimentation was 10% of the volume. So luckily the lake was large enough. It's not a threat to the quantity of water at the present time, but it is a significant amount of water. Here's one of the tributaries that goes into the lake, and this, of course, is an aerial image taken in 1997. This is the lake, and this is the tributary coming into the lake. One of the things you'll see is this is a pasture or just a grassed field, and the next photograph is from 2010. You can see there's been some development ongoing, and the sediment that was released or disturbed by the construction of this subdivision, you can now see the sediment has grown from approximately this location in 1997 all the way up to here in 2010. 2016, the sediment has encroached into the lake even further. In this particular tributary to the lake, the storage capacity of this portion of the reservoir decreased by 46%. This is another one of the main tributaries to the lake. Is referred to as Binion Creek. Same thing, you can see some sediment being deposited in the lake in 1999. In 2010, you can see the emergence of dry land from sediment accumulation during flood stages in a much larger area. And of course, in 2016, we're actually seeing more of a channelization of what was emergent soils. And this is North River. This is the main body of the reservoir and the main river that was dammed to create the lake. And you can see the different amounts of sediment. Over the years, it continues to grow. Much more of a channelization of the sediments, and it's making its way further down the lake. So we did a study of where is the source of the sediment. In in the area of the lake is predominantly a forested area. There are a number of unpaved roads through the forest. And these unpaved roads, we determined, contributed a significant quantity of sediments to the smaller tributaries during precipitation events. And this is the best management practices. Basically, it's a rock check dam that we built across a drainage from a dirt road. Now, this steel post is a 2-meter fence post that we used as a staff gauge to measure the accumulation of sediment within this catch basin. This is the same catch basin after a couple of years. And if you look right here, that's the top of that 2-meter high fence post, indicating that we've collected a 2-meter thick layer of sediment, and we've prevented that sediment from reaching the reservoir. It's a very cost-effective, simple mechanism in preventing capacity reduction. We installed 5 BMPs and we captured 458 cubic yards of solids from 2013 through 2016. So that in itself is basically 94,000 gallons of reservoir storage that we very simply prevented from ever getting into the reservoir. These were the groups that we worked with in performing those activities, and we really appreciate their services. Any questions?
Thank you, Dr. Abner. Okay, is there any questions for him?
Thank you so much for Professor. Thank you. Just I have a small question with Abner. Can I ask?
Yeah, please.
Okay. Dr. Abner, nice to meeting you through this Zoom platform. Really, I'm so happy after so long.
That is correct.
Yeah, due to this COVID, we're supposed to meet you in the last year also. This Corona, this COVID issues, we are changing our plan. I hope you are going to meet as soon as possible.
Without a doubt.
Yeah, thank you. I know you are doing a lot of consultant work in the reservoir storage capacity prevention in Alabama areas and around some part of the US. I know the Alabama, you are getting a maximum rainfall, the half of the rainfall compared with South Africa. Your average is 650. You are getting more than average, I think close to 1,000. I'm not sure. I think by mistake. I think close to 1,500 millimeter.
That is, yes.
Yeah. So in some cases in the agricultural area, is in that much, is there any water logging issues is affecting the agriculture area? Is one point. Another thing is the reservoir, the storage, the capacity, the large volume of the sedimentation is deposited in the reservoir areas. Is there any time period how you are going to monitoring that deposition of the sedimentation in the reservoir? That's all the question.
Within the city of Tuscaloosa, they're looking at bathymetric surveys of the reservoir on a 10-year cycle to keep tabs on the quantity of sedimentation that has occurred. The concerns that some of the group has is the eutrophication of the water and the growth of algae in sediment-laden areas. Now, you also asked about agricultural areas and inundation with that amount of precipitation. And yes, last year there was a delay in the ability to plant the seasonal crops because the fields were too wet to plant. And of course, during harvest time, that also impacts the harvest, because if the crop may be in the field, but a wet field, the crop itself, the quality of the material can't be harvested until it's dry. And otherwise it would mold and spoil. So that does impact things. And depending upon where you are geologically, identifies whether a public would use either groundwater or surface water. For example, the city of Atlanta, it's situated on a granite monadnock, and there is no groundwater available for the city of Atlanta. So they have to rely completely on surface water. City of Tuscaloosa resides or is located right on the fall line. North of here, there is not very much groundwater because of the rock types. It's sandstone, siltstones, and shales. South of the city is the coastal plain, and there are a lot of wells that supply water from sands and gravels of the coastal plain.
So, Dr. Abner, hello.
Yes.
Oh, how do you, I have some small query, two queries. How do you manage the desilted sediments? And is there any pollution problem in the sediments which desilted and we are dumping somewhere? Is it anything like that? You have faced any problem like that?
For the most part, there's not an issue with pollution in the sediments. There is a little bit, we do have a mercury issue that's, I think, been attributed to atmospheric deposition, but not from the actual sediment going into the reservoirs.
So you will manage, you will use it for any fertile agriculture or something like that, the desilted sediments?
I'm having a difficulty understand what type of sediments?
No, if you desilted sediments, when from the reservoirs, you are desilting, no?
Oh, I'm desilting. We're capturing
sediments.
We would capture it before it ever gets into the reservoir.
Okay. No desiltation you will do. Okay.
No. Once at least in Lake Tuscaloosa, where the tributaries are depositing the majority of the sediments is in the upper reaches of the lake. And the intake that supplies the city is very close to the dam. And so just the natural fallout of the sediments occurs in the upper reaches of the lake.
Do you use any bioshield to reduce the sedimentation? Bioshield? Green?
No, that again, the city, and it concerns me, but the city doesn't seem to be too concerned about removal of the sediments. The water treatment process is just a sand filter at the water treatment plant for our water supply.
Okay. Thank you, Dr. Abner. It's nice to know that something, a reality you are doing in the field. And I hope, Jonathan, can you conclude it with all this?
May I a question for Abner and Dr. Ramanathan?
Yes, of course you can ask.
Thank you. Abner, thank you very much for your lecture. It's an academic question, a scholar question. Do you receive students? You have program for receiving students for the postgraduate or graduate students?
I do not know.
Okay. Thank you.
Jonathan, can you?
Yeah, I'm there.
Conclude.
Yeah, when no other questions are there, I thank all the panelists for this last session of the day. And it was good interacting one with from all disciplines, not alone hydrogeology, from different disciplines were there. And I thank our chairman also, and I thank Dr. Vetri Murugan for this opportunity to chair the last session. Thank you very much, and thanks. See you in the final aspect. Final program.
Anybody is having question for Jonathan, because I was interfering. COVID is very important. Anybody want to ask? You can ask him.
Or you can send an email also, because.
Actually, I have one question. I was thinking to ask one question.
Please ask.
If you don't mind, I can ask, Prof.
Yeah, please.
Okay, I know about Professor Jonathan research area is much concentrate on the coastal environment, mainly particularly in the tourist beach environment and related to beach sediment enrichment, mental enrichment factors. He did a lot of work. But for this corona, after this COVID pandemic issues, I think in South Africa, also in most part of the world, most of the beaches, they closed for a few month periods. In that cases, if we studied already in some particular areas, for example, we did some work in the KwaZulu-Natal coastal areas. We studied for the metal enrichment in the tourist beaches. So again, if you further if you plan to continue the studies, is there any possible to identify the differences between the before and after COVID issues in the beach sediment, the metal concentration on the beach sediments? That's I want to ask with the Prof. Jonathan.
The main aspect is in sediments, I don't know whether it will be reflected directly, but in water samples, I think it will be reflected. And fortunately, we went for a field survey in the Mexican coast, and we are having the samples, and the analysis is almost over, and hope we can see the difference pre-COVID and post-COVID. So we have the analysis in both the seasons, during the lockdown and before the lockdown. So in water sample, I think clearly we can see, but sediments, I have my doubt. Thank you.
If
Thank you.
Jonathan, if there is more of accretion rate is high in the region, like our longshore current drift in the west coast, if there is accretion is reduced or increased, that from that you can able to, because if there is no disturbance, only longshore current will be playing.
Yeah, that can be seen, but that is based on current, no. But for metal concentration, I'm not sure where if it will be seen.
Then it will not come from the land. It should be
come from the tourist.
Maybe you can. You are the expert. You have to think over that.
Water sample, I think clearly we can see that.
Yeah. Okay, Vetri Murugan, hand over to you. And
thank you so much, Professor Ramanathan and Professor Joe. Is excellent coordinating for as a chair of the last sessions. Really, it was an amazing experience with you both. I'm not sure my colleague Julie is available. Okay, anyway, I would like to ask. Yes, Julie.
Yes.
Please,
I was going to ask Ryan if he can come on and just give the closing remarks so that we can conclude today's session.
Brian?
I just saw him online.
Yeah, I am here. Can you see me? Yeah.
Yes, thank you.
Okay, I've been given this job to close the whole story off. Firstly, good afternoon, morning, evening, night, wherever everyone happens to be. Firstly, I'd like to thank everybody for joining with us at this rather unique event, certainly for the University of Zululand. I really have been impressed by the quality of the papers presented and the breadth of the subject matter that we've covered, and the breadth of the planet as well, which has been covered, because we've been all over the place here and it's been really quite special. Such a gathering obviously depends an awful lot on technology, and that plays its part. We've had a few minor glitches, but the technical people seem to have managed to get us through that, and the whole thing ran pretty much like clockwork. Apologies to participants who may have had to be active at times of the day when they wouldn't normally be busy, but that's what we get when we're using pretty much the whole world from west to east. To the thank yous, we are deeply indebted to both the South African National Research Foundation and the National Natural Science Foundation of the People's Republic of China. Without their participation, this obviously wouldn't have happened. Also to the two universities, Shanghai University in China and Zululand here. Both of them have contributed enormously to the success of this venture, and we thank them very, very much. Yesterday's introductory speakers, I thought, did a wonderful job. They set the conference off with a magnificent start, and words of wisdom and words of encouragement really did get everything going nicely right from the beginning. From us at the Department of Hydrology, we really do want to thank our top management, the VC, the DVCs, and other members for their unvarying support for us doing this venture. COVID made it rather difficult, and as a result of that, we were starting to lose hope and things might not be possible, but in the end, everything came good. To all the panelists and chairs of sessions, thank you for being very professional. Thank you for the insight you've shown. Your timekeeping was amazing. I've not been or involved in conferences where timekeeping has worked quite so dramatically as it did here. And finally, and the presenters, without them, obviously the conference wouldn't have happened. Thank you very much. We wish you good luck in your continuing research. Hopefully you'll get together with new collaborators you might have met through this platform. And to the two conference chairs, Prof. Lee and Prof. Vetri, thank you very much for getting this all together. You've excelled with your scientific programming committee and your organizing committee, and everything seems to have worked very well. And to close, I would hope that we get the chance to perhaps repeat this initiative around the world in a virtual manner, and perhaps sometime in the, I fear, fairly distant future to start meeting face to face again. So handing you back to Prof. Vetri for a final word or two, all I can say is thank you all very, very much. Thank you.
Thank you so much, Brian. Really, I will appreciate your value concluding remarks. Really excellent. I know how you are supporting for us, how you are supported for this conference, successfully completed this conference. Really, it's great. Thanks, big thanks for you. Dear colleagues, I think thank you so much for your presence and excellent presentations. Really, last 2 days, I thoroughly enjoyed. I'm so happy. Finally, I would like to say a big thanks to my colleagues in Tuli, who is hosting these academic sessions since yesterday. I know we had a lot of communications, the technical issues, everything, but final output is highly commendable. And finally, I'm very happy to see my colleague after so long trying Professor Hirata. Professor Hirata, thank you so much. Yeah, yeah, this is the happiest moment. Actually, I was thinking whether I can miss him because from morning he's trying to try to come back through the Zoom. I think his camera have some issues. Thank you so much, Professor Hirata. Definitely we will work together. Yeah, I'll communicate with you. I hope everything is fine. My colleagues, really participant and speakers and chairs, big thanks from the chairperson of the conference. Thanks a lot. I think truly I would like to ask you to close this session.
Before I wind up and conclude today's session, Prof, can you just give us an indication? There's been a request from some of our delegates and they would like presentations from our speakers from yesterday and today. So I think what would be easier if there are requests, if they can be directed to you, and then you can liaise with the speakers of the different sessions and they can send the slides to you and then we can then forward them to those that are interested.
Yes, definitely, truly. Actually, this conference platform is running. One side is a live telecast through the Facebook, our University of Zululand Facebook link. Already we circulated to all the participants. Another thing, this conference is completely recorded. All the speakers come from day first, we completely recorded. All the presentation will be uploaded into our YouTube platforms. Another things, if any delegates or speakers would like to view their presentation slide, definitely send an email or any communications, any issues if you have, please contact me through the email. I will respond to you immediately. Definitely. Thank you so much.
Thank you. In that event, then I'd like to say thank you to everyone from UniZulu and enjoy the evening, enjoy the rest of your day, and thank you so much for your participation and engagement during the 2 days. Thank you. You can now leave the session. Thank you.